Good afternoon, everyone. We'll wait for 2 more minutes to start our session. Okay, last class we studied the concept of ideal or instantaneous sampling, where we put that when sampling less than or equals to 2 times the highest analog frequency, there is a chance of aliasing problem. To reduce aliasing problem, we are using a pre-alias filter that is named as anti-aliasing. After that, we checked signal reconstruction. Then we observed the practical forms of sampling like natural sampling and flat top sampling. Flat top sampling problem name is aperture effect. To cancel the aperture effect, we are designing an equalizer. Equalizer means it is used to compensate the losses or not. Okay. Let us discuss the concept of band pass signals. Why we are using sampling of band pass signals? I have not observed. Some of you are unable to stop the emotion. Background I have not seen. Okay. Let us discuss the sampling of band pass signals. Why we want to take band pass sampling concept separately? Let me explain. Suppose a band pass signal extends from 80 to 100 kilohertz. If you want to apply our ordinary low pass sampling, that is band limited sampling, we require minimum sampling rate of 200 kilohertz. But if you apply band pass sampling concept, we may require only 40 kilohertz. Instead of 200 kilohertz, if we apply 40 kilohertz, what is the advantage means? The sampling rate reduces means speed requirement of A to D converter is also reduced. Not only that, it also reduces the amount of digital memory for storage. So let me discuss the concept of band pass. Sampling of band pass signals. In communication, we are calling them as narrow band signals also in communication language. Sampling of band pass. Assume this is the band pass spectrum we are having. If this is the band pass spectrum we have, so the advantage is what, sir? It reduces speed requirement of A to D converter as sampling rate is decreased. That is one advantage. It reduces the speed requirement of. It also reduces the amount of digital memory necessary to capture a given interval of continuous signals. In comparison with low pass sampling, This is the advantage. One advantage, speed requirement of A to D converter is reduced. Another advantage, it also reduces the speed digital memory that is necessary to capture a given time interval of continuous time signal. Okay. If a band pass signal or band pass spectrum extends from FL to FH, lower frequency, higher frequency, what is the theorem means? To retain all the information, in a band pass signal without aliasing, the minimum sampling rate needed equals to 2 into FH by K, where K is the largest integer not exceeding K equals to FH by FH minus FL. FH minus FL is the bandwidth of the band pass spectrum, sir. FH minus FL. To retain all the information in a band pass signal without having aliasing problem, the minimum sampling rate needed is 2 into FH by K, where K is the largest integer not exceeding this number. Assume in the question K value is 3.6. Suppose in the question we got K number as 3.6, sir. We should take 3 or 4. 3 we should take. Largest integer not exceeding the number. That is for least sampling rate. Other choice on sampling rate is there, because generally we are not using critical sampling. Other choice of sampling rate is 2FH by M less than or equals to Fs less than 2FL by M minus 1, where M can be varied from 1 to 3, etc. K. For the largest integer K, we are getting the least sampling rate, but generally we will never go for critical sampling. So the other choice on sampling rate means they can lie in this range. 2FH by M less than or equals to Fs less than 2FL by M minus. Suppose in our example K value 4. For K equals to 4, we are getting the least sampling rate. But what are the other numbers for M? 1, 2, 3 also we can take. 1, 2, 3 also we can take. So how these conditions are correct, that we are checking from example. Derivation is very lengthy, 3-4 pages. So directly from the example, we are cross-checking how they are correct. Okay, directly from the example we are checking. Let us see how to get the least sampling rates. Are first we have to solve for K equals to FH by FH minus. After obtaining that number, we are in a position to know the least sampling rate. Okay. Suppose we have chosen a band pass spectrum like this. If we have chosen a band pass spectrum like this, which extends from 4 to 6 kilohertz, how to sample it? We have chosen a band pass spectrum that extends from 4 to 6 kilohertz. How to sample it? So what are the lowest and highest frequencies here? 4K and 6 kilohertz. 4K and 6 kilohertz. Okay. See that what we stated. K is the largest integer not exceeding K equals to FH by FH minus FL. First we have to calculate K. Then we are in a position to know the least sampling rate or not. First we are solving for K. FH by FH minus FL. See in our question what is FH and FL, sir? 6 and. So K equals to FH by FH minus FL means 6 by 6 minus 4, answer becomes 3. Luckily we got integer. Suppose if it is 3.6 or 3.7, then also we should take 3 only. Largest integer not exceeding the number we got. For k equals to 3, we are obtaining the least sampling rate. So what is the least sampling rate relation, sir? 2 into fh by k. To obtain the least sampling rate, 2 into fh by k. So 2 into fh is 6 by k. 2 into fh is 6 by k. Answer becomes 4 kilohertz or not? Answer becomes, everyone see here, m value, choice on the sampling rate, filter required to recover our original spectrum. What is the filter needed to recover our original? We got 3. As k number is 3, what are the other possible values of m, sir? 1 and 2 also. As k is 3, as k number is 3, other possible values of m are 1 and 2. For each value, we have to check the respective sampling rate and get the answer for each value. Anyway, first we are solving for the least sampling rate. What is that least sampling rate we got, sir? 4 kilohertz. 4 kilohertz. Listen everyone. Last class, what we observed, the sampled spectrum contains original spectrum and shifted replicas of the spectrum. The sampled spectrum contains original spectrum and shifted replicas of that spectrum or not. Suppose what is the spectrum of sampled signal when you are sampling this band pass spectrum at this rate? Let us make an observation. What is the spectrum of sampled signal? Let me draw that. Spectrum of band pass signal sampled at 4 kilohertz. What is the spectrum of band pass signal that is sampled at 4 kilohertz? So what does the spectrum of band pass signal contains? Generally, what is the spectrum of sampled signal contains there? Original spectrum and shifted replicas of same. We are sketching x of f minus nfs or not? We are sketching x of f minus nfs. So from the previous slide, what is the range of original band pass spectrums are 4 to 6. If you are substituting n place 0, it is our original spectrum as it is or not. If you are substituting n place 0, 4 to 6 as well as minus 6 to minus 4. N equals to 0, our original spectrum. What is the meaning of n value 1? If you substitute n place 1, spectrum right shifted by 4 units. If the spectrum, original spectrum right shifted by 4 units, where it is going to cover, sir? If you make right shift of 4 units, minus 2 to 0 as well as 8 to directly substitute n place 1, original spectrum right shifted by 4 units. If you take n value minus 1, sir, what is the meaning of n value minus 1? X of 4 plus 4k, x of f plus 4k, original spectrum must be left shifted or not? The spectrum must be left shifted, such that where it covers. This is for n equals to minus 1. Only to show variation, I am using different color pens. They are all shifted version of original spectrums only. Okay, like that. The shape may be repeated. Like that, the shape may be n equals to 0, our original spectrum. N equals to 1 means as fs is 4 kilohertz, original spectrum right shifted by 4 units, sir. This red signal. N equals to minus 1 means left shifted. Now you tell me, everyone, to recover our original spectrum, original band pass spectrum range is what, sir? 4 to 6. To recover our original band pass spectrum as it is in this case, which filter is needed? To recover back our original band pass spectrum as it is, which filter we need? Come on, which filter is needed? Very good. A band pass filter is needed. We are going to use a band pass filter. Roughly I am sketching. It is not exact curve, sir. which will have cutoff frequency slightly less than 4, more than 6, like 3.8 or 3.9, 6.1 or 6.2. To recover back our original X of f, which is a band pass spectrum, in the first case we need which filter? It requires a band pass filter. It requires, like that we have to check for other two numbers, m place 2 and first we checked for least sampling rate. How to get least sampling rate? Solve for k. K equals to fh by fh minus fl. We got 3, sir. For k equals to 3, we obtained the least sampling rate. So the spectrum of sampled band pass spectrum will appear like that. Band pass signal that is sampled at 4 kHz has appeared. So to recover back X of f as it is, we need first case band pass filter. Very good. Make a note. First we solved for least sampling rate case, sir. First we solved for least sampling rate. Very good. Most of you answered. Very good. Similarly, we have to check for other chance also. We have observed by shifting with sampling rate of 4 kHz, this as the spectrum. Spectrum of sampled signal is looking like this. Spectrum of sampled signal is looking like this. Okay. That is first for least sampling rate, sir. Let us go for m equals to 2. If m value is 2, what we mentioned in the first slide, the other choice on sampling rate is this range. K equals to 3, that we obtained, sir, the least sampling rate. If m is 2, as k is 3 in this question, m possible numbers we have written neatly 1, 2, 3. 1, 2, 3. Tell me, if I substitute m place 2 here, what is the range, sir? fh less than or equals to fs less than 2fl. fh less than or equals to fs less than 2fl. fh less than or equals to fs less than 2fl means in our question 6 kHz less than or equals to fs less than 8 kHz. If I substitute m place 2 here, everyone see here, first slide, m place 2 fh less than or equals to fs less than 2fl. That is what I have written here. fh number 6 are, fl 2 4s are 8. Okay. So for m equals to 2, what is that range? 6 kHz to 8 kHz. 6 kHz to 8 kHz. Good. If it is 6 kHz to 8 kHz, let us draw again 6 to 8, any number we can take, sir. What is the spectrum of this band pass signal? Sampled at 7 kHz. Greater than or equals to 6 less than 8 means we have chance of choosing 7 number. So what is the spectrum of this band pass signal sampled at 7 kHz? We have the chance is there. 6 to 8 in a number we can take. I am taking 7. I am taking. Let us try what will be the shape now. Let us try what will be the shape now, sir. So what is the shape of x of f minus nfs? Okay. N value 0 means our original spectrum as it is. n value 0 means our original spectrum as it is. N value 1 means original spectrum right shifted by how many units? N value 1 means original spectrum right shifted by 7 units such that it covers from 1K to 3K. This is in kilohertz scale, as well as 11 to 13. 11 to simply adding 7, right shift of 7 units, 7 kilohertz units. Okay. If you take n value minus 1, same, our original spectrum left shifted by how many units, sir? Our original spectrum left shifted by 7 units. If original spectrum is left shifted by 7 units, it is going to retain the graph something like that. There is repetition of the images. Like that, there is repetition of the images. So in this case, we need which filter? Again, to recover our original XF. To recover back our original spectrum as it is. Now also we are going for band pass filter only. Correct or not? Now also we are going for band pass filter. To recover back our original X of F as it is, now also we need band pass filter. Okay. When you sample at 7 kilohertz, in the second case also we require band pass filter. Okay. I hope you have completed the spectrum. Let us see what will happen for m equals to 1. If m is 1, what will happen to this expression, sir? If m is 1, fs greater than or equals to 2 times fh less than infinity. Infinity is anyway meaningless. Means it becomes simply what? Fs greater than or equals to 2 times fh, that is 12 kilohertz. Last case is looking like ordinary low pass sampling or not, 2 times the highest analog frequency concept. Last case is looking like ordinary low pass sample. Okay. Everyone see this table, sir. M equals to 3 means sampling rate exactly 4 kilohertz. M value 2 means 6 to 8. M value 1 means greater than or equals to 12. We have chosen a specific number. What about the other numbers? What about the other numbers? If you take any other number, there is a chance of aliasing. If you take any other number, there is a chance of. In our list, 9 kilohertz is not there. Everyone see the table. In our list, 9 kilohertz is not there. Let me explain. What is the spectrum of this band pass signal that is sampled at that is sampled at 9 kilohertz. That is not there in our list. Just to show that aliasing occurs, I am solving. Okay. Now, how we are going to visualize the graph? What is the spectrum of band pass signal that is sampled at 9 kilohertz? N value 0 means our original spectrum as it is. N value 0 means our original spectrum as it is. N value 1 means original spectrum right shifted by 9 units. Sampling rate is 9 k naught. So 9 minus 6, 9 minus 4 means where it is coming, sir? 9 minus 6, 9 minus 4 means spectral overlap is there or not? Spectral overlap is there means aliasing akkada. Aliasing akkada. Correct or not? So when you take 9 kilohertz, which is not there in our table, which is not there in the table we prepared, aliasing occurred. That is the reason how I started the statement. To retain all the information a band pass signal without aliasing, the minimum sampling rate is needed is this. This is the other choice. If you take any number other than the table, if you take any number other than the table, 100% there is chance of what? Aliasing. 9 kilohertz is not there in our list. By choosing 9 kilohertz, there is aliasing or not? There is aliasing. That is a point of observation. Okay. Let us see the spectrum of this band pass sampled signal in the last case also. What is the last case we said, sir? Fs greater than or equals to 12k. You have chance of choosing any number you like. Any number you can take, more than 12. Okay. So let us draw the last case also, sir. What is the spectrum of this band pass signal that is sampled at 14 kilohertz? Greater than or equals to 12, I am taking 14. Greater than or equals to 12 means I am taking 14. So what is x of f minus nfs now? X of n value 0, our original spectrum as it is. N value 0, our original spectrum as it is. Okay. N value 1 means it is right shifted by 14 units. N value 1 means 14. Just adding 14, sir. So where it covers 8 to 10, 18 to 20, that is for n equals to 1. N equals to minus 1 means same spectrum left shifted by 14 units. Same spectrum left shifted by 14. That is for n equals to minus 1. N equals to, like that, here also there is repetition of the images. In the last case, which filter is needed, sir? In the last case, which filter is needed? Tell me. You can go for band pass or low pass, but low pass is sufficient because low pass can be designed even with first order. Band pass means minimum 2 energy storing elements we need or not. So in the last case, it requires low pass filter. In the last case, it requires low pass filter. The least sampling rate we require for sampling this bandpass spectrum is 4 kilohertz. But in the last case, it is 12 kilohertz, more than 12, any number we can choose. So if you want to apply ordinary low pass sampling concept here, it is asking 12K. But if you are using directly the least sampling rate of the system, it is asking only 4K. That is what I mentioned. It reduces the speed requirement of A to D converter in comparison with low pass sampling. Before last year in ISRO, this theoretical question was asked, what are the advantages of band pass sampling? These 2 points. That is the reason I have written very neatly. Before 2 years, that model was asked, what are the advantages of band pass sampling over low pass? Means it reduces the speed requirement of A to D, and it also reduces the amount of digital memory that is necessary to capture a given interval of continuous signal. Some fellows will give a wrong thought by assuming this FH minus FL as B. Some fellows in the textbooks will give a wrong thought. 2B to 6B is the range, sir. You can sample a band pass signal when it is lying in the range 2B to 6B. 2B to 6B. That is a wrong logic. Why 2B to 6B we cannot choose every number? Now only we have checked for 9 kilohertz which we are aliasing akkada or not. So don't follow that stupid logic. Blindly follow this condition. The least sampling rate formula is what? 2 into FH by K. How to get K, sir? FH by FH minus FL. K is the largest integer, not exceeding the number we got. I have given an example like 3.6 means take 3, 4.7 means take 4. But generally we are not taking critical sampling case. Other choice on sampling rate is like this. Till now in our competitive exams they have asked for least sampling rate only. But you are not preparing the paper. They may ask the question like, which of the following sampling rate ranges we can avoid aliasing? Which of the following sampling rate cases we can avoid aliasing? Okay. How the speed reduces? Arey bacha, once the sampler and quantization is reduced, speed requirement is not reduced. You are using just 4 kilohertz instead of 12 kilohertz. So whatever the switching action is done, number of samples are decreased means storage is decreased. Automatically A to D converter, better A to D converter we can use or not? Don't expect the question always for least sampling rate. You can expect the question, what is the other choice on sampling rate where we can avoid aliasing? Means this range 2FH by M2, 2FL by M minus 1, sir. 2FH by M2, 2FL by M minus. Please answer me this question, everyone. A band pass signal extends from 390 to 410 kilohertz. Find the minimum sampling rate. I am asking directly least sampling rate needed. Make a try. A band pass signal extends from 390 to 410 kilohertz. Find the least sampling rate. Find the least sampling rate. FL, FH numbers are 390 and 410. Think and answer me. FL, FH numbers are given 390 and 410. We want the least sampling rate now. Whatever the number you like, you give. No problem. 40, 41, 42. Come on. Enjoy karo. FL 390, FH 410. First we have to solve for K. What is K, sir? FH by FH minus FL. 410 by 410 minus 390. 41 by 2 means 20.5. But for getting least sampling rate, we should take 20.5 as 20 or 21. 20, largest integer not exceeding the number we got. For k equals to 20, what is the minimum sampling rate required? 2 into fh by k means 2 into 410 by 20. .5 means we should go for a 20 number. We should go for 20 numbers, sir. Don't take emotionally 21. Abbo, who is this fellow? 22.7. Accurate answer. .41. But if you apply 2B logic, Ghana, what is B here? 410 minus 390 is 20, sir. 2 into 20, 40. Gone. Correct answer is 41 kilohertz. Okay. You must be careful. Don't apply that stupid logic 2B to 6B. That is a mistake. There must be some condition on B, sir. B must be integer multiple of FH like that. How for last case LPF? Arey bacha. Low pass filter can be designed even with first order, na? Band pass means minimum 2 energy storing elements we require. Design a low pass filter with cutoff as 6.1 or 6.2 kilohertz. Sufficient. Low pass filter can be designed even with first order. Band pass, band stop, minimum 2 energy storage elements are needed. Over. Our main emotion is to reduce the cost only, na? Less money, more concept. This question may be asked this way also, just I am giving idea. A band pass signal has a center frequency FC, sir. Center frequency FC 910 kilohertz and a bandwidth of 8 kilohertz. Find the minimum sampling rate. If this way question is given, a band pass signal has center frequency 910 kilohertz. Bandwidth of 8 kilohertz, asked for find the minimum sampling rate. Then what is the emotion? Come on, think. Center frequency 910. A drowsy fellow, 2 low pass filters indicates individually 2 first order filters only, na? Again it becomes second order filter means band pass only, na? Are over action. Build up fellows. Oh, last night you have designed and came morning to the class. Like that you are giving build up. Last night only you have designed band pass sampling and came to morning class. Center frequency 910. Some graph roughly I am sketching. And how much bandwidth it is covering, sir? 8 kilohertz. Means what are these numbers? 914, 906. Similarly on the negative side. Center frequency 910. Correct or not? So now you know what is FL and FH numbers. FL 906, FH 914. Instead of giving band pass spectrum directly, indirect buildup. Okay. You can solve K equals to FH by FH minus FL. With that logic, everybody can solve now. Okay. .03 kilohertz. This is center frequency FC. Last year ISRO paper signals very easy questions for asked, sir. But before last year, that is conducted in December, they have shown what ISRO, one excellent question was asked on band pass sampling. Think and answer. ISRO question. For a band pass signal with the FC equals to 1200 megahertz and bandwidth equals to 100 megahertz, which of the following sampling rate will cause spectrum inversion? Which of the following sampling rate will cause spectrum inversion? Options. For which number you are going to get spectrum inversion is the question. Center frequency 1200, bandwidth 100 megahertz. What is the meaning of this spectrum inversion is positive baseband will have inverted shape of negative baseband of the original spectrum. How to understand that word? Rough example, positive baseband we have taken like FL to FH like this. What is the inverted shape of this one? So when you draw the spectrum of band pass signal, if this shape has appeared, for that frequency spectrum inversion caused. That is the meaning of spectrum inversion. Positive baseband will have inverted shape of negative baseband of the original spectrum on the positive side only. Think and give me the answer. These are the options given. Yes. I did not get even a single answer from you. ISRO aspirant, show your emotion. 114 K number. Can you solve till 114 number? Spectrum inversion meaning is positive baseband spectrum I have drawn like this. What is the inverted shape that will be there when you shift the spectrum? That shape must appear here. That shape must appear. Positive baseband will have inverted shape of negative spectrum. Negative side spectrum will be like this, na? That shape must appear on the positive side. It is one of the very good question that is asked from one book called as DSP, Understanding DSP by Richard Lyons. Understanding DSP. I'll give the book name also. Understanding DSP by Richard Lyons. The title of the book is Understanding DSP, but if you study that book, nothing you will understand. Because so many practical way that is prepared. Funny thing is, this question is first chapter, 6th or 7th page, not this question. The meaning of spectrum inversion. First chapter, 6th or 7th page, he will explain this concept. You think of after that the story. Actually, solving FL, FH using bandwidth, if you solve for K, that many number of times you cannot enjoy. Okay? One of you have answered. The simple way to answer this question, there is a direct formula. To avoid spectrum inversion, the optimum sampling rate is 2fc minus b by m even. Only even integers you should take. This is one formula. 2fc minus b by m even. What is fc number given in our question? 1200. Bandwidth is 100. fc is 1200 megahertz. Bandwidth is 100 megahertz. I have given the formula to avoid spectrum inversion. The optimum sampling rate must be FSO optimum. See here, 2 into 1200 minus 100 by 2. 2300 by 2 means 1150 megahertz. We can avoid that. No chance at 1150. 1150, no chance. Divided by 2 is how much? 1150 divided by 2, 575, no chance. 575 divided by 2 is how much? 287.5. Why I am saying divided by 2? M must be even integer or not? M must be. So whenever you take even integer, first we got 1150 by 2, 575, no problem. 287.5, no problem. So 100% if you take 1600, there is a chance of observing the inverted form of the negative lobe. That is one technique. Carrier frequency 1200 indicates with bandwidth of 100 megahertz, maximum highest frequency is how much? 1250 only or not? The number that is more than 1250 will create definitely inverted shape. What is that? 1600 megahertz. 1250 is the highest frequency we have. The number which is more than that is given in the option is 1600 megahertz. So this is the actual formula we have to use for spectrum inversion. This formula, how it came, that is another 3-page derivation. Because it is asked, I am discussing that question. The optimum sampling rate is 2fc minus b divided by only even numbers we have to take. 1200 megahertz, b is 100. After simplification, 1150. I got 1150, sir. Divided by 2 means no problem. Divided by 2 means no problem. These are all valid sampling rate. Only not valid number is 1600. That is one logic. Another logic, highest frequency 1250 means any number more than that will create the negative side spectrum appearing on the positive side as inverted shape or not. That chance for 1600 megahertz. So that here actually they have shown what is signal subject. Some excellent questions are asked even from FIR filters also. Depending on the time I will discuss. Okay. 1 or 2 fellows have answered. Very good. Very good. To avoid spectrum inversion, this is the formula. The optimum sampling rate is 2 into fc minus b by m even. First I solved for one number 1150 by 2. By even means by 2, 575 by 2. So these 3 cases you will not face any problem. 1600 case we may face a problem. Till now, whatever we discussed, is Fourier transform and its applications. From last 4 or 5 days, we started our discussion. One application we studied is distortionless transmission, phase delay, group delay concepts are. Then Hilbert transform, pre-envelope, complex envelope, another concept. After that, what we studied? Autocorrelation, cross correlation with different properties, autocorrelation and cross correlation. After that, different forms of sampling, ideal or instantaneous, natural, flat top, sampling of bandpass signals. Be thorough with Fourier transform, CTFT chapter, because coming chapters I am discussing on CTFT basics. Next 1 week schedule. Other than Saturday till Sunday, classes will be there on signals. Next 1 week schedule. Whatever the other transforms I am discussing, they are all linked to which topic? CTFT topic. Be thorough with CTFT properties, continuous time Fourier transform properties. Slides are already available with you other than today's class. Okay. Let us start the new topic. Laplace transform. Listen everyone carefully, the concept of region of convergence. That point you should observe carefully, sir. ROC, region of convergence. How to give definition of Laplace is generalization of Fourier transform is Laplace. We are generalizing the Fourier transform definition by taking Laplace. Main advantage of Laplace topic is all the integral differential terms are converted to simple algebraic equations. All the integral differential terms are converted to simple algebraic equations. This statement is given by Oliver Heaviside. Normal partial fraction expansion we are also calling as Heaviside expansion, sir. Normal partial fraction expansion we are also calling as Heaviside expansion. Okay, so he is the inventor of so many things. He is the inventor of unit step function. Unit step function is also called as Heaviside's unit step function. Don't feel when you study that because one side is heavy, its name is Heaviside. Oliver Heaviside, he is the inventor of step function. He is the inventor of filter. The modified form of Maxwell equations are also given by this fellow. Modified form of Maxwell's equation. There are so many applications. Whatever the partial fraction expansion every day we are doing, it is linked to Heaviside only. First, let us observe the meaning of this one. Why we said generalization of Fourier transform is when you are applying input like e power st, a complex exponential input, where s is a complex variable given by sigma plus j omega, where s is a complex variable given by sigma plus. Then for the LTI system, the equivalent output we are writing as same input multiplied by transfer function. H of s is called as the system function or transfer function. It is eigenfunction logic. Input exponential means output is also exponential. Input is exponential term means output is exponential. Okay. How that is true means from convolution integral we can prove that. Our convolution definition is what? Integral x of t minus tau h tau d tau. There if you substitute that will create this term. So in general, Laplace transform of a signal x of t is defined as xs equals to integral x of t e power minus st dt. Integral x of t e power minus st. Laplace transform of a signal x of t is defined as this way. But what is s here, sir? A complex variable given by sigma plus. When you substitute sigma plus j omega, what will happen on the right side? X of t e power minus sigma t e power minus j omega t dt. X of t e power minus sigma t e power minus. In comparison with Fourier transform, what is missing on the right side in Fourier, sir? E power minus sigma t is missing. Okay. So in terms of Fourier transform, how to write Laplace means x of s equals to Fourier transform of x of s equals to Fourier transform of xt e power minus sigma t. The advantage of Laplace is if the original signal is unstable signal, it may be converted to stable signal because of this real exponential that is multiplied. If x of t is unbounded, that can be made as bounded. Not only that, when you take cos or sine functions, they are oscillating signals or not. You can make them as damped sinusoid by simply multiplying by extra which term? E power minus sigma t. Cos and sine functions are oscillating signals. They can be made as damped sinusoid by extra multiplying by e power minus sigma t. So how to express Laplace in terms of Fourier transform means Fourier transform of xt e power minus sigma t becomes Laplace. Once you take sigma number 0, automatically the complex variable s becomes j omega. See here everyone, once you take sigma 0 s equals to j omega, it means Laplace and Fourier definitions are equal. So how this is shown in the complex plane? S plane means sigma is the real part of s, j omega is the imaginary part of s. Whenever the Laplace transform is calculated on the j omega axis, it corresponds to Fourier transform. Laplace transform calculated on the imaginary axis corresponds to Fourier transform. Variable sigma Laplace fixed sigma on the y-axis. What is the fixed sigma number? 0. On the y-axis, fixed sigma number is 0. Then it becomes Fourier. X-axis Laplace, y-axis is like Fourier. That is the reason this statement generalization of Fourier transform is Laplace transform. Actually, Fourier transform will do only steady state analysis. Steady state analysis. But Laplace transform will do both transient and steady state analysis. Laplace transform will perform transient as well as steady state analysis, sir. Just recollect our control subject. When you are learning block diagram, signal flow graph, time domain analysis, Routh-Hurwitz criteria, root locus, till there it is transient. After that, what is our enjoyment? S plays j omega to check frequency response or not. Bode plot, Nyquist plot, all these concepts are. So Laplace transform will perform both the transient and steady state analysis. Fourier transform is doing only what? Steady state analysis. So what multiplier that makes difference for this chapter, sir? Original signal extra multiplied by e power minus sigma t. Everyone see the cursor. Original signal multiplied by e power minus sigma t. What is its job? If x of t is unbounded, that can be made as finite for a certain value of sigma. If original signal is oscillating signal, like cos or sine function, if original signal is oscillating signal, that may be converted to damped sinusoid also. So why we said generalization of Fourier transform is Laplace, sir? By making sigma 0 in this definition, Laplace Fourier definitions are equal. Indirectly, the complex variable has become j omega. So Laplace transform calculated on the imaginary axis. Laplace transform calculated on the imaginary axis corresponds to what? Fourier. Laplace transform calculated on the imaginary axis represents Fourier transform. Okay. That is the point of observation. What is the convergence condition of Laplace transform? Listen. Which is called as region of convergence, ROC. ROC of Laplace transform, region of convergence. It means when x of s is finite is the question, sir. When x of s is finite. See, from the definition, when x of s is finite means, if I take magnitude to the definition of Laplace, sir, if I take magnitude of e power minus g theta is 1, then what we are left with? Magnitude of e power minus g theta 1 means integral mod xt e power minus sigma t dt. Integral modulus of xt e power minus sigma t dt less than infinity. If this condition is satisfied, then only the respective Laplace is defined, which is a necessary condition. Any signal that fails this condition means you cannot take Laplace of the respective function. Any condition that is failing this integral condition means any signal that fails this condition means you cannot take Laplace. Fourier transform, I hope you have remembered. There I have written 3 points. Fourier transform is defined for stable and energy signals. Fourier transform of power signals is defined as approximation to energy. It is not defined for neither absolutely integrable nor square integrable signals. These are the words we used. 3 different conditions, sir. 3 different conditions. But in Laplace, no such condition. Any signal that is failing this integral condition means you cannot define Laplace of the respective signal. Why the word region of convergence means whatever the Laplace answer we are defining, whether it is finite or infinite, it is decided by sigma. In my explanation, you will understand that whatever the Laplace answer we are defining for a signal, whether it is finite or infinite, that is decided by sigma term. That is the reason instead of convergence, we are calling that as region of convergence. Next 20-25 minutes, listen carefully. Next 20-25 minutes. Because if you understand ROC, then only you will understand this chapter. Every fellow knows Laplace formulas, that is not important. Okay? Understanding ROC concept is most important, sir. Everyone concentrate on my discussion. The ROC points. Let us take Laplace of certain signals with ROC. If we take e power minus at ut real part of a greater than 0, why I am saying specifically real parts are ROC is decided by sigma. A may be complex like 2 plus J3. But ROC is decided by sigma. That is the reason to be specific real part. Most of you know it is a decaying exponential. Most of you know it is a decaying exponential. Do we know Fourier transform this signal or not? Please respond, sir. Decaying exponential, do we know Fourier transform or not? E power minus at ut, answer is no or not. The fixed formula, most of you know. Those who have studied properly, 1 by a plus j omega is the answer. Very good, very good. Some of you have responded. 1 by a plus j omega. Assume for some time we have not studied Fourier transform topic. Assume for some time we have not studied Fourier. After finding the Laplace of this signal, we can cross-check whether Fourier transform exists or not. Listen carefully. After finding the Laplace of this signal, we can observe whether Fourier transform exists or not. Respond. What are the integration limits to be varied, sir? It is a positive-sided function. 0 to infinity e power minus at multiplied by e power minus st. That is 0 to infinity e power minus of s plus a into t dt. Further enjoyment, e power minus of s plus a into t divided by minus of s plus a over the limit 0 to. Now I am checking this convergence condition, sir. If I replace s as sigma plus j omega, if I replace s as sigma plus j omega in the exponential power, let us see what will happen. What is the real part of this exponential? Sigma plus a is the real part. Sigma plus a is the real part. Don't bother about j omega. Because once you take modulus of x of s here, mod e power minus j omega t becomes 1. Mod e power minus. What must be this real part nature such that it is a finite Laplace? The problem is upper limit t place infinity. T place 0, answer 1 only. Whether sigma plus a is negative or positive to make this as finite Laplace. Whether sigma plus a is positive or negative to make finite Laplace. If I assume this as negative, sir, negative into negative becomes positive. T plus infinity e power infinity is gone. Sigma plus a positive means positive into negative becomes negative. T plus infinity e power minus infinity 0. So we can say 1 by s plus a is the answer under what ROC condition? Sigma plus a greater than 0. To be specific, real part of s greater than real part of minus a. Sigma is nothing but real value of s or not. This is what we are calling as ROC. Okay. So e power minus at ut Laplace pair with 1 by s plus a under this condition. See here everyone. E power minus at ut Laplace pair with 1 by s plus a with ROC as what? Sigma greater than real part of. How this is shown in the S plane is, how this is shown in the S plane. We have a pole at minus a. We have a pole at. The first property of ROC of Laplace is, listen, the first property of ROC of Laplace is, ROC of Laplace transform consists of lines parallel to j omega axis. That is the first property of ROC, sir. ROC of Laplace transform consists of lines parallel to j omega axis. ROC of Laplace transform consists of lines parallel to j omega axis. Why we are taking parallel to j omega axis means, the reason is, when we said Laplace and Fourier definitions are equal, sir, on the j omega axis or not, we are taking these parallel lines to know two things. One thing, for this signal, this Laplace answer is valid only for which region? You take any value of sigma from minus a to infinity, it is convergible. We used the word region of convergence. What is the region? Minus a to infinity. Convergence means 1 by s plus a finite. This 1 by s plus a becomes finite value only for the region minus a to infinity. That is not only the reason, we are in a position to decide whether Fourier transform of the signal is defined or not. In this case, Fourier transform is defined because ROC includes j omega axis. Whenever the ROC includes j omega axis, for that signals Fourier transform is defined. Whenever the ROC includes j omega axis, for that signals Fourier transform is defined. Blindly S place you can substitute j omega, not for every signal. Be careful. We are taking these parallel lines for another reason, to know whether Fourier transform of that signal is defined or not. One more observation is, ROC should not contain any pole. What is the reason why ROC should not contain any pole? You got Laplace answer as 1 by s plus a. What happens if I substitute s place minus a, sir? If I am substituting in the Laplace, answer becomes infinity. Our convergence condition is what? It must be finite number. But at the pole, what is the Laplace answer, sir? When you substitute the pole, answer becomes. That is the second property of ROC. ROC does not contain any poles. If pole is included, Laplace answer becomes infinity or not. ROC does not contain any poles. That is the reason I have taken half circle to exclude the pole. So for this signal, this Laplace answer is valid for what region? Minus a to infinity. For this signal, this Laplace answer is valid for the region minus a to infinity. Less than minus a, it is unbounded signal. Region of convergence 1 by s plus a is finite only for which region? Minus a to infinity. And the last observation in my explanation is, everyone tell me, decaying exponentially stable or unstable? Its area is finite or not? Decaying exponentially is stable. What is stability condition in Laplace is, for stability in Laplace transform, ROC must include j omega axis. If you want to maintain stability in Laplace, ROC must include. So for which type of signals you can convert Laplace to Fourier, sir? Only if ROC includes j omega axis. Not everywhere. Be careful. Only for the signals which are including j omega axis, directly s place j omega you can substitute. Directly s place j omega you can substitute. Okay. Why the lines parallel to j omega axis means, when Laplace and Fourier answers are equal, when s equals to j omega, they are equal. That is the reason we are taking parallel lines to j omega axis. Laplace and Fourier definitions are equal from our first slide of this chapter. Only when s equals to j omega. That is the reason we are taking parallel lines to j omega axis. ROC should not contain any pole. What is the reason for that? At the pole, Laplace answer becomes infinity. Where I checked the convergence conditions are in the last step, sigma plus A. Whether this is negative or positive to make that as finite Laplace. In this case, it is greater than 0, positive. Okay. Understand ROC, that is most important for us. ROC, region of convergence. For which type of signals you can convert Laplace to Fourier? Only the signals which are including j omega axis. For that signals directly S place you can substitute j omega. Directly S place you can substitute j omega. Not for every combination of signal. First you draw S plane, sir. Sigma is real part of it, j omega imaginary part of S. We have a pole at minus A. I assumed A is real pole. If it is complex, somewhere it will lie here. The first property of ROC, ROC of Laplace consists of lines parallel to j omega. Why that parallel lines are taken means Laplace and Fourier definitions are equal on the j omega axis. That is one reason we are taking that. Second reason, whether Fourier transform of original signal is defined or not, that point also we can check. If ROC includes j omega axis, Fourier transform exists. That is the first property of ROC. Second property, ROC does not contain any pole. What is the reason for this, sir? If I substitute S place minus A, that pole answer becomes infinity. It is not convergible. So ROC should not contain any. Another observation, decaying exponential is a stable signal. This signal is stable. So to maintain stability in Laplace domain, ROC must include what? Imaginary axis. Okay? Then only stability is guaranteed. For stability in Laplace domain, ROC must include j omega axis. If A is real number, no need to write real parts, are A may be complex. That is the reason specifically greater than real part of minus A. Specifically greater than real part of minus A. Okay, that is the first signal. Every one of you know, even Fourier transform, that signal is defined. The second standard signal which we are studying is this one, minus e power minus at u of minus t. Minus e power minus at u of minus t. This is the second standard signal. Everyone tell me what is the Fourier transform of this? Come on, friends. Good. Only one fellow positive response till now. No Fourier transform. It is an unstable signal. The second formula we studied is e power at u of minus t. Sir, see here carefully. I have given minus e power minus at u of minus t. It is an unbounded signal. There is no Fourier transform for this signal. That I can explain from ROC. What just if ROC is not including j omega axis, no Fourier. If the ROC is not including, let us see what are the integration limits now. Minus infinity to 0. Signal is minus e power minus at multiplied by e power minus st dt. Minus infinity to 0 minus e power minus at into e power minus st. So that is e power minus of s plus a into t, e power minus of s plus a into t. So it becomes further e power minus of s plus a into t divided by minus s plus a over the limits minus infinity to observe the convergence condition s place. Again what we are substituting, sir? To observe the convergence condition, s is replaced as sigma plus j omega. S is replaced as sigma plus what is the real part of the exponential? What is the real part now, sir? Sigma plus a. Now the problem is the lower limit minus infinity is the problem or not? Everyone tell me, we should take sigma plus a as negative or positive now to make finite Laplace. We should take sigma plus a as negative or positive, sir, to make finite Laplace now. Come on, I want response from you. Okay, background noise I will take care of. Sorry for the disturbance here. Okay. What is this sigma plus a such that we can make that as finite Laplace means? Suppose if I assume this as positive, sir. Positive into negative becomes negative. T plus minus infinity gone. E power infinity. But if this is negative, negative into negative becomes positive. T plus minus infinity means e power minus infinity 0. So answer is 1 by s plus a under the condition sigma plus a less than 0. To be specific, sigma less than real part of minus a. Sigma less than real part of, correct or not? So everyone tell me how this is shown in the S-plane. How the ROC is shown in the S-plane now. We have a pole at minus a, but what is ROC now we are saying, sir? What is ROC now we are saying? Less than that pole. Don't include the pole. Lines parallel to j omega axis. Don't include the pole lines parallel to j omega axis or not. Tell me. Don't include the pole lines parallel to j omega axis. This ROC gives us the clarity that no Fourier transform. ROC is not including j omega axis, so no Fourier transform. Laplace is also not defined everywhere, sir. Very good, very good. Most of you answered my sigma plus a question. Very good. Laplace is also not defined everywhere. For what region this 1 by s plus a becomes finite? Only for the region minus infinity to minus a. 1 by s plus a answer becomes finite only for the region minus infinity to minus a, not everywhere. It is convergible only for this region. No Fourier but Laplace exists. No Fourier but Laplace exists. It is not stable, ma. It is not stable. Convergence is different, stability is different. Don't mix the word. Convergence is different, stability is different. I have shown the graph which is neatly looking like unstable at minus infinity, its amplitude is minus infinity. Don't mix the words convergence and stability. Don't mix them. What is the observation you can make from the first signal and second signal? First signal e power minus at ut Laplace 1 by s plus a. Second signal minus e power minus at u minus t Laplace 1 by s plus a. Both have same Laplace. Correct or not? Let me write the relations here. First relation we derived as e power minus at ut Laplace pair with 1 by s plus a sigma greater than real part of minus a. What is the second relation? Minus e power minus at u of minus t also having the same transform sigma less than real part of. Can anyone tell me what is the observation we can make? Laplace solution is same but the time domain signals are different or not? Laplace solution is same but the time domain signals are different. It means solution of Laplace transform is unique only when the ROC is given. Solution of Laplace transform is unique only when the ROC is given. Solution of Laplace transform is unique only when the ROC is. If the ROC is not given, you can write any answers. For 1 by s plus a, this relation correct, this relation also correct, sir. If ROC is not mentioned in the problem, answer is not unique. Okay, good. Solution of Laplace is unique only when what is given. If ROC is given, then unique answer. If it is not given, right side signal you can write, left side signal also you can write. Any answer is valid. Okay. What is the Fourier transform of e power at ut with positive a? What is the Fourier transform of e power at ut with positive a, sir? It is an unbounded signal. Fourier transform is not defined. Unbounded. Growing. There is no Fourier transform for that function. Very good. Does not exist. Very good. No Fourier transform. Let us see the Laplace with ROC. Integral 0 to infinity e power at into e power minus st dt. It is a positive side function 0 to infinity e power at into e power. Further it is taken as e power minus of s minus a into t. S place what we are substituting, sir? Sigma plus j omega. Sigma plus directly substituted here. S place sigma plus j omega. What is the real part now? We got the real part like sigma minus a now. We got the real part like sigma minus a. Now it is positive or negative, sir? I hope everyone can respond this. Problem is upper limit infinity is the problem or not? If sigma minus a is positive, positive into negative becomes negative. T plus infinity e power minus infinity 0 or not? Laplace is 1 by s minus a under the condition sigma minus a greater than 0, sigma greater than real part of a. So how this is shown in the S plane is, we have a pole at A, we have a pole at, but what is ROC now? Shaded portions there. greater than the this ROC clearly tells us no Fourier transform. It is not including j omega axis. It is not including. How the Laplace exists for this unbounded signal? Let me explain. Everyone see my graph. See here. The convergence condition which we have stated is this in time domain integral mod xt e power minus sigma t must be finite. So this is xt's are growing. It is extra multiplied by e power minus sigma t. It is extra multiplied by e power minus sigma t. Sigma is depending on a. Sigma is depending on a. A is positive or negative here? Positive. For your understanding purpose, I am assuming sigma as 5, some number 5. Sigma as 5. Such that what is the shape of e power minus 5t? Normal decaying type. For your understanding purpose only, I have chosen that number sigma as plus 5. Sigma is greater than a positive, sir. So sigma is positive. When I multiply both the signals x3t e power minus sigma t, what will be the resultant graph? An increasing exponential multiplied by decaying means overall becomes decaying. Don't feel emotionally constant. It is not positive ramp added to negative ramp. This is a growing exponential multiplied by decaying means overall becomes decay. Original signal is unstable, but the new signal x3t e power minus sigma t is stable because of which term? E power minus sigma t has made the difference, but you can take sigma value only in the range a to infinity, not according to your convenience. You can take sigma value only between a to infinity. Only for your understanding, I have chosen this number 5. Don't feel it is my favorite number. Only to say that it is acting like a decaying exponential, I have chosen this number. Original signal becomes unstable, new signal is stable because of sigma. Sigma depends on a or not, sir? Sigma depends on a. So that is the third relation we have. E power at u of t Laplace pair with 1 by s minus a sigma greater than real part of a. Sigma greater than real part of this is unstable signal. Laplace is defined only for certain region. Only for certain region. In a similar way, we can also show that minus e power at u minus t Laplace pair with 1 by s minus a sigma less than real part of a, sir. Sigma less than real part of. With these 4 relations, we are discussing this entire chapter. With these 4 relations, we are discussing this entire chapter. Learning is over how to remember in easy manner. ROC concepts, all these things we have learned, but how to remember these formulas in easy manner. Every one of you tell me by seeing this slide, out of the 4 formulas which we have written, sir, for which formulas Fourier transform is defined? 4 relations we have written on this slide. For which formulas Fourier transform exists? Fourier transform is defined only for which case? First and last case Fourier transform exists because they are including what? ROC. Bachas, I hope you have remembered this. E power at u minus t is 1 by a minus j omega. Take minus sign this side, sir. Growing exponential. Middle two are unstable, only Laplace exists. How to remember the formulas in easy manner? Stop writing and observe here, everyone. Observe the slides, sir. First two formulas both contains e power minus at Laplace 1 by s plus a. First two formulas both contains e power minus at Laplace 1 by s a. 1 by s plus a. Multiplied by ut means right-sided signal or not. Multiplied by ut means right-sided signal ROC greater than that pole. Multiplied by u minus t means left-side signal ROC less than that pole. Similarly, third, fourth. E power at means what is the answer? 1 by s minus. Multiplied by ut means right side greater than that pole. Multiplied by u minus t means left side less than. Left-sided signal compulsory opposite sign. One example to give for you, easy example I am giving. 1 by s plus 5 is given. 1 by s plus a means, first everyone write blindly what? E power minus at. 1 by s plus a means we'll write e power minus a. If you have decided that it is a right side signal, what you have to multiply in the time domain, sir? If you have decided that it is right side signal, what you have to multiply? Ut. If you have decided that it is left side signal, what you have to multiply? Minus u of minus t. Minus u of minus t. That is the concept. No need of by hearting the formula. Right sided signal multiplier ut, left side signal minus u of minus t. Every one of you, most of you, instead of saying everyone, most of you are very good in Laplace formulas. The only new enjoyment here in signal subject is ROC. How to write ROC? Based on ROC, how to write time domain function? After writing inverse Laplace, if you feel signal is right sided, what is the multiplying factor? See the cursor, ut. If it is left side, what is the multiplying factor, sir? Minus u of minus t. Those who are in drowsy mode, please wake up and say with me. Right-sided signal multiply by ut. Right-sided signal multiply by ut. Left-sided signal multiply by minus u of minus t. Right-sided ut. Left-sided minus u of minus t. With this emotionally, we are going to complete this chapter. Everyone say with me. Come on. Those who are sleeping at your home, they should wake up immediately. Come on, show your emotion. Sunday, no enjoyment for you. Okay. Right sided is ut. Left sided is what, sir? Minus u of minus t. Right side signal multiply by u of t. Left sided signal multiply by minus u of minus t. That is the logic we require, sir. Okay. So we have understood what is ROC by sketching the graph. But easy way of remembering the formula is this logic. First 1 by s plus a is given means what you have to write first? E power minus at. If it is multiplied by ut, right side signal, if it is multiplied by minus u of minus t, if it is multiplied by minus u of minus t, that is left sided signal. Okay. Right sided signal ut, left side signal minus u of minus t. Very good. For which signals you can convert Laplace answer to Fourier answer, sir? Only if the ROC includes j omega axis. Only if the ROC includes j omega axis, then only you can convert Laplace to Fourier. Only if the ROC includes j omega axis. Correct or not? What are the beginning properties of ROC? We have taken first properties, what we have written. ROC of Laplace consists of lines parallel to j omega. ROC does not contain any pole, and we said for stability in Laplace, ROC must include what, sir? J omega axis. Okay. The next property of ROC is if x of t is of finite length, then the ROC is entire S-plane. If you take a finite duration signal, then the ROC becomes complete S-plane. What are the examples? Any finite duration signal means ROC convergible everywhere. If you take impulse functions, blindly its Laplace is 1, as it is not depending on S. ROC convergible everywhere. Entire S plane. Suppose I have chosen a rectangle from 0 to 3, sir. Without finding its Laplace, what you can say? What is ROC for the signal without finding Laplace? Complete S plane, because length is finite. 3 units are not. Length is finite. 3 units. ROC becomes complete. Even if you find how to write this in terms of step functions are ut minus u of, means what is the Laplace answer? 1 by s minus e power minus 3s by, which becomes 1 minus e power minus 3s by. Normally, if you substitute the pole location till now, in our previous case, answer becomes infinity. S plus 0 if you substitute infinity previous case. But here enjoyment is different. What is limit s tends to 0 x of s, sir? If you substitute s plus 0, 0 by 0 indeterminate condition. If you get indeterminate condition, what you will do? L hospital. Numerator differentiation is what, sir? 3 e power minus 3s. Denominator 1. There also it becomes finite or not. So what is ROC? Complete S plane. Any finite duration signal means ROC convergible everywhere. Any finite duration signal means ROC convergible everywhere. Complete S plane. Complete S plane. There is no need to find the Laplace and decide the answer, sir. Any finite length signal means ROC becomes complete S plane. Okay. Any finite duration signal means ROC is complete S plane. L hospital approval for time domain only. You are all champions in mathematics here. I don't know who has defined that rules for you. Come on, brother. It is applicable. For a delta function, we get infinite, sir. Wake up, bacha. Integral del t e power minus st dt. Sunday है ना ज़्यादा कह लिया शायद. Integral xt into del of t minus t naught. Whenever impulse integral contains impulse, sampling or shifting impulse exists at 0 e power 0 1. Don't get emotion, रे. सोचो पहले सोचो. Think. हाँ. Any finite length signal means ROC becomes complete S plane. Any finite length signal means ROC becomes complete S plane. That is the reason after I am also sleeping, bacha. But because I know the subjects, simply I am saying, if you see my face, you will know that. Slightly difficult, but no problem. Subject wise, no problem for you. Laplace, when I am teaching, it is like music for you. A.R. Rahman music. Only it will go ROC. Right-sided ut, left-sided minus u of minus t. Very easy. It is like music for you. First 2 hours of Laplace transform is very simple, sir. In the last 2 hours discussion only, you will know what is actually this topic. First 2 hours, very easy for everyone. Last 2 hours only, there are certain points to be observed. Listen carefully. Okay. The beginning formulas which we have defined are for single pole, only one pole. Only one pole means how to get the Laplace. But when you have multiple poles, if you take a rational Laplace with multiple poles, how to find out the time domain signal? Suppose we have taken like this, s by s plus 1 into s minus 3. How to find out the time domain signal? See here, everyone. What are the residues? S place minus 1, if you substitute, minus 1 by minus 4 is 1 by 4. S place minus 1. S place, if you substitute 3, sir, answer becomes 3 by. First you do partial fraction expansion. First you do partial fraction expansion. Okay. Then, based on the possibilities, we are finding the time domain signal here. Based on the possibilities, everyone should listen carefully. The first possibility is, if you want to take the signal as a right-sided signal, ROC becomes right of rightmost pole. If you want to make the signal as right side signal, ROC is right of the rightmost pole. We have a pole at minus 1, another pole at 3, sir. Which pole is right of the rightmost? Which pole is right of the rightmost, sir? 3. So we should choose the ROC as what? Sigma greater than 3. Sigma greater than. Everyone tell me, what is your observation from ROC graph? With respect to the pole, see the cursor, sir, everyone. With respect to the pole minus 1 ROC right side, with respect to pole 3 also ROC right side. When you write the inverse Laplace, both are multiplied by UT or not? Say with me, what is the answer? 1 by 4 e power minus t multiplied by UT right sided. 3 by 4 e power 3t multiplied by UT right sided. With respect to both poles, it is right side. First chance. Second chance, signal is left sided. Second chance, signal is ROC is left of the leftmost pole. ROC is left of the. So which pole is looking like left of the leftmost now, sir? Which pole is looking like left of the leftmost? Sigma less than minus 1. We should take left of the leftmost pole means sigma less than minus 1. So what is the observation from ROC graph, sir? With respect to pole 3, where is ROC? Left side. Left side of us. With respect to minus 1 also, left side. When you write the answers, both are left side signals. Come on, tell me what we have to multiply left side means. E power minus t multiplied by minus u of minus t. 3 by 4 e power 3t multiplied by minus u of. With respect to both the poles, it is left side. That is the second chance. Last chance, signal may be two-sided. That is the last chance. Then we are looking for a common ROC. Then we are looking for where the common ROC lies. Minus 1 less than sigma less than 3. It lies between the two poles. Intersection ROC, sir. Minus 1 less than sigma less than 3. So it lies between the two poles. Minus 1 to 3. What is the meaning of the last case actually? Sigma greater than minus 1 but sigma less than 3. Pole -1 right side, pole 3 left sided. So in the last case, what is the answer? 1 by 4 e power minus t, that is the right side term, means ut. 3 by 4 e power 3t left side means minus u of. We have the same transform but different types of signal representation based on the ROC. We have the same transform but different types of signal representation. For a right-sided signal, ROC becomes right of the rightmost. Everyone see the cursor? Why can't we can take sigma greater than -1? If you take sigma greater than -1, ROC includes a pole which is wrong. That is the purpose of right of the rightmost. Suppose if you feel sigma greater than -1, our shaded portion includes pole 3. That is wrong concept. Left side signal, left of the leftmost, two side means common ROC. In your coming year GATE paper 2021, there is chance of MSQ, multiple select questions. This type of question can be framed by giving Laplace. Which of the following Laplace solutions are correct? Which of the following time domain signals are correct with different ROC? All three options are correct here. Answer is same, but all three options are correct or not? Based on the ROC. Based on the ROC. Control system, there is no anti-causal or non-causal. There is no ROC also in controls. Even in network theory, there you feel every signal is positive side signal. All combination of signals we are learning in signal subject only. All combinations. Signal right-sided, left-sided, two-sided, causal, anti-causal, stable, unstable. Oh, multiple words. Control system, you feel every signal is positive sided. There is no ROC requirement there. But here, based on the ROC only, we can find out the respective time domain functions. In the last case, ROC includes a 0. Shaded portion can include a 0. It should not contain any poles. Everyone place your finger on the pole and you see with respect to your finger, it is right side or left side. If it is right side, multiply by ut. If it is left side, multiply by which term? Minus u of minus t. Greater than 3, less than -1. Where is the intersection, bacha? If you say it is greater than 3, less than -1, what is the intersection ROC? 0 ROC. Keep it in your pocket. What you will do with that? No intersection ROC. Those who are in drowsy condition, please wake up. Take one deep breath. Stop for 2 minutes. You will get freshness automatically. Bode plot is done for steady state response sinusoids. S equals to j omega only. Will substitute not sigma, bacha. Steady state response. If sigma segment is also included, it will come under transient and steady state. Sigma j omega components. Bode plots, Nyquist plots are drawn only for steady state response concept. I am going to discuss that models. Don't be tensed. Just starting up the chapter only. Everyone tell me which case it is stable. Which case it is stable, sir? Last case it is stable. ROC is including what for us? J omega axis. Only last case it is stable. Without doing any integration, we observed stability or not. Normally till now, what is our overaction stability means? Integral mod h tau d tau less than infinity. That is not at all needed. That is not at all. So whenever you have multiple poles, how to decide the ROC? Based on the condition given, we should write the time domain function. Here I have shown 3 chances for you, 3 different chances. Last case it is stable because ROC is including j omega axis there. Don't forget when you are writing inverse Laplace, bachas, right-sided signal multiplier ut, left-sided signal multiplier minus u of minus t. But in this simple example, if you have done partial fractions wrongly, 2021 number becomes 2022. You must be careful or not. Be careful. Partial fractions are also equally important. Wantedly, he may give one of the option with opposite signs. You must be careful or not. Do partial fractions carefully. Okay. Please answer me this model. Find the Laplace of the given signals with ROC. We are adding the signals Laplace only when they have common ROC, sir. Indirectly, linearity principle. If individual signals ROC is like R1, R2, sir. You can add the signals Laplace if they have common ROC, R1 intersection R2. Check one by one. Add the respective Laplace only when they have common ROC. What is the first combination? E power minus t ut added to e power minus 3t ut. Laplace of first term is what, sir? E power minus t means 1 by s plus 1. Ut means ROC greater than that pole. Ut means right side signal. What is the Laplace of second term? 1 by s plus 3 sigma greater than. Can we add the Laplace? Answers or not? Respond. 1 by s plus 1 plus 1 by s plus 3. Right of the rightmost pole. Which pole is right of the rightmost? Sigma greater than minus 1. We can add the transforms because common ROC is there. Right of the rightmost pole. Second signal e power minus 2t ut added to e power 4t u of minus t. That is the second signal, sir. Think and answer me. Common ROC exist or not? Come on, friends. Think and answer me. Good. Minus 2 to 4. What is the Laplace of the first term? 1 by s plus 2 sigma greater than, what is the Laplace of second term? 1 by s minus 4 with opposite sign. Don't forget left side compulsory opposite sign. U minus t means plus becomes sigma less than. So what is R versus R? Minus 2 to 4. Add the transforms. Common R versus lies between minus 2 to 4. Add them. You can add the answers. Common R versus lies between minus 2 to 4. What about the third combination? Third signal, come on. Good. No common ROC. Very good. What is the Laplace of first term? 1 by s plus 1 with opposite signs. Sigma less than. What is the Laplace of second one? 1 by s minus 5. Sigma greater than. One is purely left side, other one purely right side. Less than minus 1, greater than 5. There is no common ROC. Automatically there is no Laplace. Common ROC is not there means Laplace transform is not defined. No common ROC, no Laplace. Fourth bit it is asked for. What is the Laplace of 1 for all time? We want Laplace of 1 for all time, sir. 1 for all time means it is sum of two signals. Positive time ut, negative time u minus t. Positive time ut, negative time. Laplace of ut 1 by s sigma greater than 0. Laplace of u minus t minus 1 by s sigma. No common ROC. No Laplace. Don't get emotion. We studied one Laplace is 1 by s. In networks and controls, 1 means step function only. 1 for positive time is step functions are, but 1 for all time there is no Laplace. 1 for positive time step function. 1 for all time there is no Laplace. But what is the Fourier transform of 1 we have defined neatly? 2 pi del omega. Whereas here no Laplace. Correct or not? Next we want signum function Laplace. Signum. What is the Fourier transform of signum we know? 2 by j omega. 2 by. Now we want Laplace. Again no Laplace. Because what is signum in terms of step function? Ut minus u of minus t, same as our previous problem. Same as our. No common ROC, there is no Laplace. Don't create the answer. As we have 2 by j omega, writing here 2 by s means gone. Don't show your creativity. Without common ROC, Laplace is not possible. Last one is a two-sided exponential e power minus mod t. Last one is a two-sided exponential. Two-sided exponential can be selected as sum of decaying and growing. Sum of decaying and growing, sir. Laplace of first term 1 by s plus 1 sigma greater than Laplace of second term 1 by s minus 1 with opposite sign, left sided u minus t means opposite. Sigma less than, we can add the Laplace because common ROC is there. We can add the Laplace, sir. Minus 2 by s square minus 1. ROC now includes j omega axis or not? Minus 1 less than sigma less than 1 means ROC includes j omega axis automatically. Which transform exists? Fourier exists. Substitute s plus j omega minus 2 by minus omega square minus 1, which is 2 by. Every one of us know two-sided exponential Fourier transform is this answer or not? We neatly studied e power minus a mod t, 2a by a square plus omega square. 2a by a square plus omega square. Common ROC lies between minus 1 to 1, sir. That indicates it is including j omega axis means automatically Fourier transform exists. It includes j omega axis means automatically Fourier transform exists. Correct or not? Tell me. So whenever we are adding the signals, the respective Laplace transforms can be added only when we have common ROC. Only when we have common ROC. Otherwise, we cannot add them. Common ROC is compulsory. Okay. Yes. First think and answer me the left side question. Consider the signal e power minus 5t ut added to e power minus beta t ut with its Laplace xs. What are the constraints on real and imaginary parts of beta to get ROC real part of s greater than minus 3? One fellow on previous page. Just a minute, sir. See it. Okay, I'm going to next page, ma. Think and answer me. It is neatly mentioned. We want to know real part of beta and imaginary part of beta constraint. After 10-15 minutes, I'll give break. Don't be tensed for a break. Emotional fellow. If you have any urgency, go and come back. 2-3 minutes. Have a cup of tea. Otherwise, anyway, you are at home only, na? Freshness you will get automatically. It is neatly asked about real part and imaginary part. Great fellow, MSD. He has retired, huh? Oh. Like MSA, multiple selective questions, MSQ, MSD. Great man. Wonderful human being. Good. Good, good. Only 2-3 fellows have answered it. Good. Laplace of first term is 1 by s plus 5 sigma greater than minus 5. Laplace of second term is 1 by s plus beta sigma greater than real part of minus beta. We are specific because we have to decide the nature of beta. It is mentioned real part of s greater than minus 3. Already we have a pole at minus 5, sir. This ROC indicates compulsory real part of beta is 3. Why? Both are right side signal means ROC is right of the rightmost pole. Both are right side signal. So ROC is right of the rightmost. Based on that point, real part of beta, imaginary V is arbitrary. Any value can be valid. No constraint on imaginary. The reason, you may take the pole zero plot something like this. You may take in this case the pole zero plot something like this. Or you may take the same pole zero plot like this also. Minus 3 plus J7. Then also the ROC is decided by minus 3 plus J7 means then also the ROC is decided only by real part. You take J 10 power 5, who will ask you? We don't bother about imaginary. ROC of Laplace is always decided by sigma or not? ROC is decided by, that is the reason real part is 3, imaginary, arbitrary, any value valid. Any value is valid. Okay? Very good. Most of you answered very good. E power minus beta t ut formula 1 by s plus beta. This beta can be complex number. Till now in all our examples we have taken real numbers, sir. That is the reason sigma greater than real part of minus beta. Given ROC is minus 3, already we have pole at minus 5. Right of the rightmost is this answer. That is the reason real part 3, imaginary, any value. 2 examples I have shown here. Here sigma greater than minus 3, here also sigma greater than minus 3. This right side question is funny question. How many possible ROCs are there for the given pole zero plot? How many chances? 2, 3, 4, 5, 10, 100. Come on. Very funny question. Which is right of the rightmost, sir? This sigma is very small, bacha. Okay. Which pole is right of the rightmost here? Greater than 2. Left of the leftmost? Less than. Lying between 2 poles, minus 3 to minus 1, as well as minus 1 to 2. Minus 3 to minus 1 we can take, minus 1 to 2 also. Can you take for minus 3 to 2, sir? Can you take that as minus 3 less than sigma less than 2? Gone. It includes a pole or not? Right of the rightmost, left of the leftmost, lying between 2 poles, 2 chances. Lying between 2 poles. 4 chances. Very good. This type of funny questions, I think you will show your emotion. Good, good. Yes. Previous slide, that simple model we observed is how many chances of ROCs are there for the given pole zero plot. 4 chances are there. It is not asked about causality or stability, all that build-ups are. Only number of possibilities are asked. Now you think and answer me. Left side question. Find the inverse Laplace of this expression e power minus 3s by s plus 1 into s plus 2 sigma greater than minus 1. ROC is given as greater than. ROC greater than minus 1 means right side signal or left side signal. ROC greater than minus 1 means right sided or left sided. Yes, for unstable to define ROC, I'll give the examples. Wait, sir. Laplace domain exponential term is there means time domain it is shifting. X of t minus t naught have Laplace of e power minus st naught into xs having ROC same as original. Apply this property. X of t minus t naught is having Laplace as e power minus st naught into xs with ROC same. Use that property. Take e power minus 3s separately and do partial fraction expansion for other term. Given ROC indicates it is a right-sided signal. Take exponential term separately, do partial fraction expansion for other component. S place minus 1 means 1, S place minus 2 means it is minus 1. S place minus 1 is 1, sir. S place minus 2 is. This is neatly looking like e power minus st naught. So what is the inverse Laplace, sir? First 1 by s plus 1 means e power minus t ut. E power minus t ut shifted by how many units? 3 units. 1 by s plus 1 means e power minus t ut shifted by 1 by s plus 2 means e power minus 2t ut. That is also shifted by how many units? Laplace domain exponential term is there means time domain shifting. Laplace domain exponential term is there means time domain shifting. ROC remains same because it is not changing the pole's location, sir. Very good. Given ROC indicates signal is right sided. Given ROC indicates signal is right sided. Laplace domain exponential term indicates time domain shifting. Think about this question, sir. A signal x of t is given as sum of step and ramp. Write the expression and get the Laplace. As the signal is finite length, automatically ROC becomes which plane? Complete? Yes, plane. Signal is finite length. ROC becomes complete. Find out the slope. 10 by 2. 2 to 4 constant, slope 0. After 4 constant, slope 0. So what is the first term? Ramp signal starts at origin with slope of 5. 5 into R of t. At t equals to 2, first we should cancel that effect. Till 2 it is maintaining slope of 5. First cancel the effect. Minus 5 into R of. After making 0 slope, immediately negative jump has occurred, sir. 10 to minus 5 drop. minus 15 u of t minus 2 at t equals to 4 positive jump of 5 units. 5 into u of t minus. First the ramp signal starts at origin with slope of 5 into r of t. At t equals to 2 cancel that effect, 0 slope. Introduce negative ramp, sir. But 0 slope is not visible in the graph. Immediately negative jump has occurred. 10 to minus 5 drop means minus 15 u of. At 4 positive jump minus 5 to 0 means positive jump plus 5 into u of. Every one of you know ut Laplace means 1 by s. Ramp signal Laplace 1 by s square. Extra application of shifting. So 5 by s square, 5 into e power minus 2s by 15 e power minus 2s by s, 5 e power minus 4s by. Write the given signal in terms of step and ramp function. You got the answer. Write the given signal in terms of step and ramp function. First, the ramp signal starts at origin with slope of 5 into r of t. At t equals to 2, cancel that effect. Introduce negative ramp of opposite slopes are. Then at t equals to 2, jump has occurred 10 to minus 5, minus 15 into u of. At 4, minus 5 to 0 means positive jump. After expressing the given signal in terms of ramp and step, we got the Laplace. No need to mention its ROC. Any finite length signal means what is the ROC we know. Any finite length signal ROC becomes complete S-plane or not? Complete S-plane. Any finite length signal, complete S-plane. A similar model is this question. Answer me. Laplace transform of certain waveform is given at the last shift if the answer is d e power minus 8s by s square. I think this is not perfectly visible. 1 plus a e power minus s plus b e power minus 4s, c e power minus 6s, d e power minus 8s. Those are the numbers. What is that d number? Very simple question. For this waveform, what is a d? This can be also written as sum of step and ramp function only, but at the last shift, what is d? Only concentrate the graph for 6 to 8 interval. What is the slope for the interval 6 to 8? d e power minus 8s by s square. What is the slope for the interval, sir? 1 by 2. 1 by 2. Height by width. Height by rising ramp. Till 8 its slope is 1 by 2, but at t equals to 8 we want the slope as 0. Till 8 its slope is 1 by 2. But at 8 we want slope as 0. So to cancel that positive ramp effect, what we are introducing? Negative ramp of opposite slope. To cancel that positive ramp, we are introducing negative ramp of opposite. D is minus 1 by 2. There is no need of writing complete expression in terms of step and ramp, sir. No need to write complete expression. 6 to 8 interval. Everyone see the cursor? 6 to 8 interval, find out the slope 1 by 2. Till 8 its slope is 1 by 2, but 8 we want new slope as 0. So to cancel that positive ramp effect, definitely what we are introducing there? Negative ramp of opposite slope. There is no need to find out the complete expression, but because that fellow wants only capital D. This right-sided question is, consider the given signal, find its Laplace with ROC. First bit I will solve, second bit you have to answer me. First bit I am solving. E power minus phi t u of t minus 1 is given. We want Laplace with ROC. You cannot solve directly, because if you want to apply time shifting property, that t minus 1 is needed even in the exponential also. If you want to apply time shifting property, t minus 1 is needed in the exponential also. Adjust that with the t naught equals to 1. So now you tell me what is the Laplace of this answer, sir? First e power minus 5 extra multiplier, 5 into 1, sir. Extra multiplier. Because of time shifting, e power minus st naught. T naught is 1, sir. Times the Laplace of original signal with ROC greater than minus 5. With ROC greater than. Find the Laplace of e power minus 5t u of t minus 1 asked. Here for the application of time shifting, what adjustment is needed in the power? T minus 1 plus 1, 5 into 1 e power minus 5 extra multiplier. Because of shifting e power minus st naught times Laplace of original signal. First bit I answered, second bit every one of you try and tell me. Second bit is, now he wants to select a left-sided signal. If g of s, x of s answers are equal, that is what here the build-up, same algebraic form of xs. If g of s, x of s answers are equal, what is the value of a and t naught for which the answers are same is the question. Now it is a left side signal. Everyone find out its Laplace and equate the answers. Now it is a left side signal, sir. Everyone find out the Laplace and equate the answers. Do the required adjustments. Tell me for which value of a and t naught answers are same. For which value of a and t naught answers are same. Only one fellow, two fellows passed to answer till now. Two fellows. Left-sided signal, for which value of a and t naught it will happen. Again, what adjustment is needed? T plus t naught minus t naught. U of minus of t plus t naught. Now it is in the correct form. When you take Laplace here, g of s equals to a e power of phi t naught minus 5 into minus t naught means phi t naught. Because of time shifting, e power minus s into minus t naught times Laplace of original signal 1 by s plus 5. Left-sided signal, what is the sign? Don't forget. It is a left side signal means compulsory opposite. Sigma less than As GS XS answers are equal, by comparison, A is -1, T naught is -1. As GS XS answers are equal, A is -1, T naught. First you adjust T plus T naught. -5 into minus T naught extra multipliers are. Because of time shifting, e power minus S into minus T naught times Laplace of original signal with opposite left sided. Sigma less than. Just compare. You know what is the end? Both are -1 is the correct answer. Some fellows emotionally gone. Be careful. Okay, take 20 minutes break. Again, we'll continue. 20 minutes break. We'll continue again. Take 20 minutes break, sir. Okay. Everyone came back. So time shifting property means in Laplace transform, the ROC remains same because it is not adding any new poles. The ROC remains same for time shifting property. Suppose if a sine wave is given like this and asked to find the Laplacer. That sine wave is defined for one cycle and asked for what is the Laplace of this function. Make it right. We want the Laplace of the sine wave. Every one of you know sin omega naught t ut means standard Laplace is what? Omega naught by s square plus omega naught square. Sin omega naught t ut standard. So how to get the Laplace of this sine wave defined for one cycle? What is the Laplace of this sine wave that is defined for one cycle? ROC can contain zeros. It should not contain any pole. Numerator roots are zeros. ROC can include zeros. It should not contain any pole because at the pole Laplace answer becomes infinity. Come on, sir. Think and answer me. Actually, it can be adjusted as a sin omega naught t multiplied by ut minus u of t minus pi. Because that sine function is defined for what intervals are 0 to pi. This bracket term represents that interval ut minus u of sin omega naught t ut. Direct answer is there, but second term we need some adjustment. One cycle period here is pi such that frequency becomes 2. One cycle period is pi such that frequency is. Graphically, how to answer this question is, see here. This waveform can be taken as a 10 sin 2t ut. A sin omega naught t ut form. What is the peak to peak amplitude variation plus or minus 10 means A sin omega naught t ut, sir. But after pi we don't want that signal means start the shifted version of the same signal with negative amplitude. Start the shifted version of the same signal with, so minus 10 sin of 2 into t minus pi u of t. Start the shifted version of the same signal with negative amplitude such that they are all cancelled. We are left with only one cycle or not. We are left with only the sum of these two functions is given signal xt. First you take 10 sin 2t ut which is there for all times, sir. For that minus, take the shifted version of the signal starting from pi with negative amplitude, cancellation of the terms, then automatically what you are left with our original. Anyway, according to time shifting here, shift is pi, sir. So the standard Laplace answer is here 10 sin 2t ut, here also 10 sin 2t ut means 20 by s square plus 4. Omega naught by s square plus omega naught square means 20 by, first time it is 1, second time causing pi units of shift, e power minus st naught. Here 10 sin 2t ut is there, here also 10 sin 2t ut is there. Omega naught by 10 into 2 by s square plus omega naught square, but it has caused pi units of shift. Pi units of shift. Instead of making mathematical adjustment, simple way to answer that question. Why 20? 10 is already there, bacha. Omega naught is 2. Numerator, omega naught 10 into 2. This 20 is nothing but 10 into 2, sir. A sin omega naught t form. 10 into 2. Instead of taking unnecessary adjustment, this is sine function that is defined for 0 to pi means a sin omega naught t multiplied by ut minus u of t minus pi. So a sin omega naught t ut is direct answer we know, sir. Second term here we must adjust like t minus pi plus pi, 3-4 steps will increase. To avoid that, what I have done, I have taken that switched sine wave for positive time. After pi, as we don't want the signal, take the shifted version of the same signal with negative amplitude. Take the shifted version of the same signal with negative amplitude, just add them. Our original graph is retained. So direct answer. So 10 sin 2t ut, here also 10 sin 2t ut means 20 by s square plus 4. As it is having shift of pi units here, e power minus st naught. E power minus st. Most important observation we have to make in our discussion, that point I am discussing, listen. Most important observation. What is that is, when we take pure periodic function like cos omega naught t, sin omega naught t, pure periodic function, Fourier exists, Laplace is not existing. But if you take switched cosine or sine, cos omega naught t ut, sin omega naught t ut, switched cosine or sine, Laplace exists, Fourier also exists. Laplace transform is not defined for pure periodic functions. It is defined for switched or causal periodic functions. Laplace transform is not defined for pure periodic. Pure periodic means which is there for all time. What is the reason? That explanation now I am giving. Listen carefully. Why Laplace is not defined for pure periodic function? Everyone listen carefully, sir. Suppose we want Fourier transform of cos omega naught t into ut. It can be selected as xt multiplied by cos in terms of exponential e power j omega naught t plus e power. I am asking Fourier. Listen first. It means we are assuming xt as ut. What is the Fourier transform of step function? Already we know. Ut Fourier 1 by j omega plus pi into del of omega. If you apply Fourier transform here, y omega equals to x of omega minus omega naught plus x of omega plus omega naught whole divided by, in the assumed spectrum omega place we are making these two replacements in the assumed spectrum, sir. So y omega answer is what? 1 by 2 into 1 by j into omega minus omega naught plus pi into del of omega minus omega naught, one term. 1 by j into omega plus omega naught plus pi into del of omega plus. No one in the world will remember this stupid formula because we don't require it. Here our observation is only how to convert this Fourier answer to Laplace answer. To convert y of omega into y of s, delete impulsive part of y omega. Delete impulsive part of y omega and replace j omega equals to s. Why I am saying the word delete the impulsive part? Observe here. Why I am saying one Fourier transform CTFT, every one of us know 2 pi into del omega. But what is the Laplace of 1 for all time? Starting problem, no answer. There is no Laplace. That is the reason to convert Fourier to Laplace, delete the impulsive part and replace j omega as s. If I delete the impulsive part, what will happen to the Laplace here, sir? Ys equals to 1 by 2 into, come on, see here, 1 by j omega minus omega naught means s minus j omega naught, 1 by s plus. After deleting the impulsive part, replace j omega as s, which is nothing but our answer. Standard, most of you know, cos omega naught t ut means s by s square plus with ROC sigma greater than 0. Because its poles are lying on the j omega axis. On the j omega axis, real part is 0 or not? The poles are lying on the j omega axis, so real part is 0. Similarly, one more well-known example every one of us know. What is ut Laplace? Step function Laplace 1 by s. What I said just now. Delete the impulsive part j omega plus yes. We got the answer or not? Delete the impulsive segment j omega plus. So now you can understand why Laplace is not defined for pure periodic function. Everyone tell me, what is cos omega naught t Fourier transform we studied? CTFT sir. Pi into del of omega minus omega naught plus del of omega plus omega naught. Now we are saying delete the impulsive term. If you delete the impulsive term, what you are left with? Not pi bachas, nothing we are left with. Nothing we are. So Laplace transform is not defined for pure periodic function. All this mathematical explanation, for what purpose I have given. Whenever you see cos omega naught t, sin omega naught t, don't write emotionally s by something or omega naught by something. That is gone. Laplace transform and jet transform are defined for switched periodic functions. Laplace transform and jet transform are defined for switched periodic function, means causal periodic. Okay. Why we have deleted the impulsive part? See here, idhar dekho. 1 Fourier transform is 2 pi del omega, but 1 for all time. What is the Laplace we observed? No Laplace, means for 2 pi del omega, no equivalent term in Laplace. That is the reason we deleted impulsive part. Later on, j omega plus substitute s sir. 1 by j omega minus j omega naught means s minus j omega naught. Here also 1 by j omega plus j omega naught means s plus. Similarly, for pure periodic function, why Laplace is not possible? Cos Fourier transform is pi into 2 shifted impulses. Already we said delete the impulsive part, nothing left. Ut Laplace 1 by s we know. See here, idhar dekho cursor. Ut Fourier is 1 by j omega plus pi del omega. Again delete the impulsive part j omega plus s. We got the answer or not? So Laplace and jet transform both are defined for switched periodic functions. Laplace transform as well as jet transform both are defined for switched periodic functions. In the coming classes discussion, if I give cos omega naught t, sin omega naught t as the input to a transfer function, you should not say emotionally s by something, omega naught by something. That is wrong. Laplace or jet transform, they are defined only for pure switched periodic functions. Laplace and jet transform, they are defined only for switched periodic functions, not for pure periodic, sir. Laplace transform and jet transform both are defined for switched periodic functions. Laplace transform and jet transform both are defined for switched periodic functions. Okay. The next property which we are discussing here is shift in Laplace domain. Like we learned frequency shifting in Fourier transform is called as now shift in S domain. What is this property is if xt Laplace pair with xs having ROC R sir, xt into e power s naught t Laplace is x of s minus s naught with ROC r plus real part of s naught. Xt into e power s naught t means the ROC changes to r plus real part of s naught, because in general s is sigma plus j omega. If it contains any real term also we have to add. In general s is sigma plus j omega. If it contains any real component also we are adding. Let me discuss few examples here. Everyone see here. Suppose it is asked what is the Laplace of e power minus at cos omega naught t ut sir. What is the Laplace of e power minus at cos omega naught t? From our previous slide you can feel this as xt, because what is cos omega naught t ut? Standard answer we know from previous slide, s by s square plus omega naught square. You can feel that like xt e power minus at. So what is the Laplace answer? Ys equals to x of s plus a. We are assuming xt as what here? Cos omega naught t. So for which the standard answer known, here s is replaced as what sir? In that expression s is replaced as what? S plus a by s plus a whole square plus with the new ROC, original ROC 0, what we have defined in the previous case, 0 plus, as we don't know about a, to be specific real part of minus a, as we don't know about. Not only that, suppose it is asked what is the Laplace of t e power minus at ut. This answer also most of you know, 1 by s plus a whole square. 1 by s plus a. Now you can feel ramp signal as reference. T into ut as reference. What is the Laplace of ramp? 1 by s square sigma greater than 0. So when you apply Laplace here, xt e power s naught t form a property style. Y of s equals to x of s minus s naught. X of s minus. In the assumed transform s place we are substituting s plus greater than 0 plus real part of minus a. Greater than 0 plus real part of. All these formulas are known to us, but without by-hearting them. Simply assuming step and ramp function as reference. Simply assuming ut and ramp as reference, we are in a position to create the formulas. Main observation here is what in our explanation, ROC, R plus real part of S naught. Original ROC plus, if S contains any sigma component, that also we have to add. In this S naught, if it contains any sigma component, that also we are adding, sir. Okay. R means original signal ROC. R indicates original signal ROC. That is represented like R. It can be anything greater than -1, less than -1, depends on the problem, sir. Original signal ROC. Okay. Shift in S domain, like frequency shifting or modulation in Fourier transform. Now we are using shift in S domain. Study this question and answer me. Let xt be a signal that has rational Laplace with the two poles located at -1 and -3. If gt equals to xt into e power 2t and g omega converges. What is the meaning of g omega converges, sir? Fourier transform is defined. In Laplace domain, what is the indirect meaning of Fourier transform is defined? If the word g omega converges, Fourier transform is defined means, what is the indirect meaning? Stability, ROC must include j omega x or not? ROC must include j omega. With this information, decide the correct option. What is the nature of the signal g of t asked, sir? With this information, think and answer me. Is it right-sided, left-sided, two-sided, finite length? Think and answer me. X of s can be taken as k by s plus 1 into s plus 3. Always introduce k multiplier some gain, because DC gain need not be 1, sir. K by gt equals to e power 2t into xt means g of s becomes x of s minus 2. Shift in s domain property. So when you replace s as s minus 2 here, s minus 1 into s plus 1. Where the poles are there for g of s are -1 and 1. -1 and. So when the ROC can include j omega axis. When the ROC can include j omega axis, only when it lies between two poles. We want stability or not, ROC must include j omega axis means when ROC is -1 to 1, indirectly g of t signal is two-sided. Question is asked for g of t. Question is asked for g of t. To maintain stability, ROC must include j omega axis. If the question is asked for x of t, then right side is correct. Question is asked for g of t, sir. If the question is asked for x of t, right side is a correct word. Question is asked for g of t. Two-sided is correct. ROC lies between -1 to 1. Combination of both right and left side signal means two-sided. The next observation which we are making here is a time reversal. If xt Laplace pair with xs having ROC as R, Laplace of x minus t is x of minus s with ROC minus R. If original signal ROC is R, reversed signal ROC minus R, that is not a big thing. First formula we derived in the chapter is e power minus at ut Laplace is what, sir? 1 by s plus a sigma greater than. If you apply time reversal property here, t is replaced as minus t, 1 by s is replaced as minus s. ROC greater than becomes less than a minus r, opposite sign greater than becomes less than. Of course, it is nothing but our fourth formula in the list. E power at u minus t is minus 1 by s minus a. E power at u minus t is minus 1 by. Main observation is checking ROC. Greater than minus a now becomes what, sir? Greater than minus a now becomes less than. Regard that. Time shifting property, we said ROC remains same. Shift in Laplace domain R plus real part of S naught. For this time reversal property, we are saying minus R. You must be careful with properties. Be careful with properties. Please answer me this funny question. Very easy example on reversal property. Study the right side expression and answer me, sir. G of t equals to xt plus alpha x minus t, where x of t is beta e power minus t ut and gs is also given. Find alpha beta. Application of linearity and reversal. Very simple question. Application of linearity and reversal, sir. What is alpha and beta? Come on, friends. What is alpha and beta? If I take Laplace here, gs equals to x of s plus alpha x minus s. Gs is mentioned as already in the question s by s square minus 1. What is x of s answer, sir? Beta by. What is x of minus s meaning? Directly s place. Left side denominator can be written as s plus 1 into s minus 1. Right side beta by s plus 1 Take minus sign common, minus alpha beta by s minus 1. Left side denominator is s plus 1 into s minus 1. Do partial fraction enjoyment. Compare. You will get the answer. When you do partial fraction expansion left side, residues are 1 by 2, sir. When you do partial fraction expansion, by comparison, beta 1 by 2 minus alpha beta 1 by 2 means alpha minus 1. Funny example. Application of linearity and reversal. Alpha minus 1 beta 1 by 2. Very simple models are s by s square minus 1, denominator is s plus 1 into s minus 1. Do partial fraction. Compare. By comparison only you know the answer. Okay. How we studied time differentiation property in Fourier transform topics are d by dt replaced as j omega. Now in Laplace it is replaced as which variable? Yes. How we studied frequency differentiation, d by d omega is replaced as minus jt. Frequency differentiation. If I drag that j in the denominator, now it becomes d by ds replaced as minus t. So d by dt becomes yes, d by ds becomes minus t. D by ds becomes minus t. Both are having the same ROC. ROC remains. Both are having the same. Theoretically, we know differentiation with respect to one variable is multiplied by other variable or not. Differentiation with respect to one variable corresponds to multiplication by other variable. That logic only. D by dt means yes. D by ds means minus t. D by dt means s multiplier. D by ds means minus t. Suppose Laplace expression is given like this and asked for time domain function. Laplace expression is given and asked for logarithm of. To convert logarithm to normal form, we have to apply differentiation. What is log a by b expansion here? Log a minus log a minus. To convert logarithm to normal form, we need differentiation, sir. So what is d by ds of xs? Log x means 1 by x. This is like 1 by s plus 3. Differentiation of log x is 1 by. So what is the inverse Laplace? D by ds corresponds to which term, sir? See the cursor. D by ds corresponds to minus t x of t. As no ROC condition is given, signal is right-sided. As no ROC condition is given, signal is right-sided. Nothing is mentioned in the problem. So signal is right-sided. Suppose in the problem x of t is left-sided, that statement is given, sir. Suppose in the problem xt is left side. what we would have multiplied here? If it is left side, minus u of minus a or not? Minus u of no condition is stated in the problem means take the signal as right-sided signal. This chance is there for you in two topics. This chance is there for two topics. With respect to Laplace and jet transform, because both are linked to ROC, sir. In our competitive exams, how you can recognize the question is framed from signals means with respect to Laplace and jet transform, you have a chance. They may use the word right-sidedness, left-sided, two-sided, causal, anti-causal, non-causal, stable or unstable, or ROC itself may be given. Sigma mod jet. Jet plane it is called as mod jet. If these conditions are mentioned automatically, it is signals example. But this question only Laplace is given without stating any condition means it is a general form. Signal right-sided. Only Laplace given without stating any condition. Signal is right-sided signal. If condition is given, we have to move by conditions, are based on the condition only we should write the inverse. Okay. To convert logarithm to normal form, application of differentiation. To convert logarithm to normal form, application of differentiation. Generally in competitive exams, the condition will be given in Laplace and jet transform chapters like this. Right-sided signal, left-sided signal, two-sided signal, causal, anti-causal, non-causal, stable, unstable, or ROC. If nothing is mentioned, take the signal as positive-sided signal. If nothing is mentioned. Please think and answer me. What is the Laplace of this function? T square u of t minus 1. What is the Laplace of this function t square into u of t minus 1? Think and answer me, sir. Get the Laplace of the function t square u of t minus 1. There are two ways to answer it. For t square, you can take minus 1 whole square d square by ds square. Previous slide for t, what you have done, minus d by ds. See the cursor. For t, minus d by. So minus 1 whole square d square by u of t minus 1 Laplace is what, sir? E power minus s by s. For t square multiplier, minus 1 whole square d square by u of t minus 1 is e power minus s by 2 times differentiate. You have to perform 2 times. Alternative, only shifting property. T square can be written as t minus 1 plus 1 whole square. I am making that shift adjustment. T minus 1 plus 1. Now it is looking like a plus b whole square expansion. T minus 1 whole square u of t minus 1, one quantity. 2 into t minus 1 u of, and the last quantity u of t minus 1. Adjust t as t minus 1 plus 1 whole square, sir. Then you take Laplace. T square ut is parabola 2 by s cube into e power minus s. Next ramp 2e power minus s by last one e power minus s by s. Even if you differentiate 2 times, what answer you are retaining? This answer only. Without differentiation only, with time shifting, we got the answer directly. Even you apply differentiation, answer will be same, sir. Anything you can do. Observe the right side example. Right side example. Consider the two right side signal xt and yt which are represented by some differential equation. We want x of s, y of s with ROC. Application of time differentiation properties are neatly. Application of time differentiation. Think and tell me what is xs, ys with ROC? Very simple model. T square u is like a plus b whole square expansion. T minus 1 whole square u of t minus 1. Second term 2ab, 2 into t minus 1 u of t minus 1. Last one t square ut parabola 2 by s cube. Ramp you know, step function you know, normal shifting. What is the Laplace of the second expression here? Sys equals to 2 times. So from which you can say y of s is 2 by s into x of s. What is the Laplace of the first term? S into x of s equals to minus 2ys plus 1. First expression, sir, s into x of s equals to minus 2ys plus. But we know y of s in terms of x of s is, y of s in terms of x of s substitute here. Minus 4 by s into x of s plus 1. You take x of s on the left side, s plus 4 by s. Answer becomes s by s square plus 4. Y of s is 2 by. What is the ROC we should write in the question? It is mentioned consider two right-sided signals xt and yt. Right side means ROC is greater than the real part of the pole. Where the poles are lying? On the j omega axis. Poles are lying on the j omega axis. Automatically sigma greater than every one of you can recognize this is Laplace of which function? Cos 2t ut. Y of s is looking like sin 2t ut. Laplace or not, sir? It is mentioned consider two right-sided signals. ROC is greater than the real part of the pole. Our poles are on the j omega axis. S square plus 4 means plus or minus j2. Plus or minus. Poles on the j omega axis means sigma greater than 0, sir. Initial conditions involved, I am discussing that as force of response, zero state. Don't get emotion, bacha. Still we are in bilateral Laplace. Unilateral Laplace separately I will deal. Don't be tense. Initial value, final value theorem. So much story is there. Suppose the Laplace expression is given like this. How to solve for time domain function? 4 by s plus 2 into s plus 1 whole cube. First, we are writing the partial fraction expansion like a by s plus 2, b by s plus 1 whole cube, c by s plus 1 whole square, d by s plus 1. When there exists repeated root, how to solve for partial fraction expansion is the question, sir. 4 by s plus 2 into s plus 1 whole cube. When there exist repeated roots, how to solve for y of t here? AB residues we will not directly, sir. For getting A residue, close this. S place minus 2 means 4 by minus 2 1 plus 1 whole cube is minus 4. Close this. S place minus 2, 4 by. B also direct. S plus 1 whole cube, S place minus 1 means B is 4. Whenever there exists repeated root, one technique is generally differentiation. D by ds of s plus 1 whole cube into y of s observed at s equals to minus 1. D is 1 by 2 factorial d square by ds square of s plus 1 whole cube into ys. General technique is differentiation. After multiplying by s plus 1 whole cube, differentiation of 4 by s plus 2 is not that much difficult. But after multiplication, suppose you got a new term like this. After multiplying by s plus 1 whole cube, suppose you got a new term like this. Can you do differentiation, sir? U by v. First time differentiation only, you will decide better to stop the problem because you require enjoyment one more time also. Correct or not? For that reason, the best and easy method is, how many unknown residues are there? 2 unknown residues. 2 unknown. Substitute any value of s in the expression other than the original roots. Substitute any value of s other than the original roots means other than minus 2, and if I substitute s equals to 0 in the complete expression, what will happen, sir? Put s equals to 0. Left side quantity 2. I am substituting s plus 0. Right side minus 2 plus 4 plus c plus d. In the entire expression, substitute s place, from which c is minus d. From which c is. One time I substituted s plus 0. Next time I am replacing s as infinity. If you want to replace s as infinity, multiply both sides by s, then you do the replacement. Multiply both sides by s. Limit s tends to infinity, 4s by s plus 2 into s plus 1 whole cube. Right side limit s tends to infinity, minus 4s by s plus 2. Next to 4s by s plus 1 whole cube. Cs by s plus 1 whole square, ds by s plus 1. If you want to replace s as infinity, multiply both sides by s, then you do the replacement. Left side quantity 0. Why I am saying s into s cube, you take common in the denominator s power 4, 1 by infinity 0 or not. S into s cube, 1 by s cube is 1 by infinity. Here ss jump to minus 4, sir. Next to 0, 0, d. D answer 4, automatically C is minus 4. We got all residues. I hope most of you are aware that formula 1 by s plus a whole power n. What is the time domain form? T power n minus 1 by n minus 1 factorial e power minus at ut. This is the standard Laplace expression. T power n minus 1 by n minus 1 factorial e power minus at. By using that, we can write the inverse Laplace. First, we will note two residues AB directly. Generally, to get C and D, repeated roots means differentiation is one technique, but it is lengthy. Substitute two different values of S other than the original roots are. I substituted S plus 0 in the complete expression from which we know C is minus D. Next, I want to replace S as infinity. If you want to replace S as infinity, multiply both sides by S, then you do the replacement. This is the conclusion. We got ABCD, substitute based on this formula, write the inverse. Based on the formula. Never you had said about it. Now you are a build-up fellow. For the first time we are using repeated roots. Who are you to decide all these things? I have never used whole power 4 or whole power 5 till now. For the first time I am solving the model. Where I have taken fourth order or third order, Fourier transform chapter or anywhere. Fourier transform only we have done partial fraction. Build up fellow. For the first time we are solving it repeated roots question. If 1 by S is there, you take other than S plus 0, anything else. General method is repeated roots means differentiation is one technique that is quite lengthy. Maybe for this problem it is easy, sir, but quite lengthy. So how many unknown residues are there? C and D, two unknown residues. How to get C and D means one time in the entire expression I substituted S plus 0, from which we can say C is minus D. Next time I want to replace S as infinity. S as infinity means to replace S as infinity, the extra carry is multiply both sides by S, then you do the replacement. Multiply both sides by S, then you do the replacement. This quantity became 0. Here SS cancellation, after taking S multiplier common, SS cancellation minus 4. Last quantity D. D became 4 means C minus 4. Every quantity known. Based on the standard formula, you can decide the answer. For your practice, the advantage or beauty of this method you will know. Not for this simple example I solved, because numerator is just 4. You will know the beauty of this method when you solve this type of question. You solve this question, then you will know. Homework. Here you will write A by S plus 1 plus B, BS plus C by S square plus 2S plus 5, sir. Only A residue means S plus minus 1 you will get. How to get B and C means same technique. One time substitute S plus 0, another time substitute S plus infinity. But never forget to multiply by S. Otherwise you will get wrong answer. Never forget to multiply by S or extra. How AB values came up? Partial fraction also you don't know. Oh, great. Close this term with your hand because I cannot close here. Close that. Rest of the term S plus minus 2 you substitute. 4 divided by minus 2 plus 1 whole cube. Minus 1 whole cube is minus 1. 4 by minus 4 is minus 4. Similarly, to get B, we are multiplying this expression by S plus 1 whole cube. Close it. Replace in the rest of the expression S plus minus 1. 4 by 1 is 4. Browsy fellows, आज ज़्यादा हो गया. I feel Sunday special you have taken more. That is the reason some simple mistakes only you are doing today. Simple things also you are asking today. Solve karo. E power minus 80 cos bt, e power minus 80 sin bt ut form you will get this expression solve karo. Whatever I got in my mind, I have framed that as question. Everything I will not by heart. Conceptually, I will move. Make a try on your own. Okay. Let me explain the next point. Convolution property in Laplace. Convolution property. X of t convolved h of t is having Laplace as xs into hs. With the ROC R1 intersection R2, if there is no pole zero cancellation, if pole zero cancellation doesn't occur, then only that is a valid ROC, sir. Convolution time is multiplication in Laplace domain. If their individual ROC is like R1, R2, we can take R1 intersection R2 if there is no pole zero cancellation. Means if pole zero cancellation occurs, ROC also changes. If pole zero cancellation occurs, ROC also changes. अरे initial condition अभी बताया ना class में. Wait for some time under unilateral Laplace. Again I will repeat that property with initial condition. अरे ड्रोजी लोग कितने बार पूछते? 10 मिनट के पहले बोला ना. Unilateral is different, bilateral is different. Now we are discussing bilateral Laplace without any initial conditions, sir. Unilateral means with initial condition. That is a separate topic. First, let us understand the meaning of this one. R1 intersection R2 if there is no pole zero cancellation. Everyone see here. Suppose I have taken Laplace of the input as 1 by s plus 1, sir. And the transfer function as s plus 1 by s plus 2 into s plus 3. Okay? To get the output Laplace. If input is causal, system is also causal. If input is causal, system causal. What is causality? Right of the rightmost pole. Take the largest pole. Sigma greater than -1. Here what is a ROC greater than? If input is causal, sigma greater than -1. If system is causal, sigma greater than -2. Normally R1 is this, R2 is this. What is the intersection of them? What is the intersection of them? We feel sigma greater than -1 we feel individually. But after multiplication, s plus 1 multiplier jumper means sigma greater than -1 ROC gone or not? This ROC is gone. Sigma greater than -1, that is gone. So what is the ROC of y of s? We have to say not greater than -1. What is the ROC? Sigma greater than -2. Listen one more time. Input Laplace I have taken as 1 by s plus 1. Transfer function as s plus 1 by s plus 2 into s plus 3. If input is causal, sigma greater than -1. Causality means right side positive time we want. Right of the rightmost pole. Sigma greater than -1. If transfer function is also causal, we feel sigma greater than. What is the intersection of them, sir? Greater than -1 we feel. But after multiplication, this pole and 0 cancel. This pole cancel means this ROC is also cancelled. What you are left with? Sigma greater than. That is what I said theoretically. R1 intersection R2 if there is no pole 0 cancellation. If pole 0 cancellation occurs, ROC also changes. If pole 0 cancellation occurs, ROC also changes. Okay? You can take direct intersection if there is no pole zero cancellation. If pole zero cancellation occurs, ROC also differs. Think and answer me this question. A causal transfer function is given as S by S plus 1. Input x of t is given as this one. Find the output with ROC. Input known, transfer function known. We want the output with ROC. Think and answer me. Causal transfer function is given S by S plus 1. Input is given. We want the output with ROC. We know ROC is R1 intersection R2 concept for us. R1 intersection. Think and answer me, sir. Everyone note down the transfer function and input and solve. Don't sit like statios. Make a try. Find the output with ROC is the question. Make a try, sir. Look for common ROC, possible or not. No ROC. For a build-up fellow, for fun I have given. You think. I will answer it. Think first. At least one fellow positive response. Come on, online. Don't be offline. By sleepy mode. Leave the drowsiness. As causal transfer function is there, ROC greater than -1. S by S plus 1 is given greater than. See here. Input Laplace, what I can write? E power t ut means 1 by S minus 1. Second one with opposite sign, -1 by S minus 2. U minus t is there means compulsory opposite. For this component, sigma greater than 1. For this component, sigma less than 2. This is right side greater than 1. This is left side, sigma less than 2. So what is the input ROC? 1 less than sigma less than 2. 1 less than sigma less than. This is simplified as minus of -1 by S minus 1 into causal transfer function. So ROC greater than -1, sir. E power t ut. E power t means 1 by S minus 1 multiplied by ut means greater than that pole. E power 2t means 1 by S minus 2. U minus t means opposite sign. -1 by S minus 2. ROC is 1 to. What is the common ROC they have? Here greater than -1 is there. Here 1 to 2 is there. So what is the output ROC? Only 1 to 2. Why? Greater than -1 meaning is like this. This is greater than -1. What is the meaning of 1 to 2? This is 1 to 2. So what is the intersection of them, sir? -1 to infinity, 1 to 2 means what is the intersection? 1 to 2 or not? Solve for Laplace of output and tell me. Hardly one fellow, two fellows have given correct answer. After giving the idea. Come on, come on. Don't be lazy, be crazy. Come on. Sigma greater than -1 is the ROC for the transfer function. Here 1 to 2 means intersection is what, sir? 1 to. Now you take ys. Y of s equals to x of s into h of s. Once you take product of them, what will happen? Once you take product of them, minus s by s plus 1 into s minus 1 into s minus 2. Take product of x's and h's. Take product of. I am not doing partial fraction. You enjoy. A by s plus 1 plus b by s minus 1 plus c by. Output contains the pole set -1, 1 and 2. We said its ROC is what? What is the ROC of output we decide? 1 to 2 or not? It lies between only. So what is the observation from the ROC graph, sir? With respect to pole -1, ROC right side. With respect to pole 1 also ROC right side. But with respect to pole 2, for the poles -1 and 1 right sided. For the pole 2, left side. A e power minus t ut, B e power t ut, both are right side. But pole 2, C e power 2t, left side means what is the multiplying factor? Minus u of We decided intersection ROC is 1 to 2. Just multiply the input Laplace and transfer functions. Input Laplace and transfer function. That has created this answer. After partial fraction enjoyment, for the pole -1 and 1, it is right side, ut sir. But for the pole 2, left side, minus u of. Very simple question only. If I teach the class, multiple selective questions easily I can prepare. Because 100 answers you will give. But only 4 answers are sufficient. We can prepare MCQ also. What are ABCD options? Your own ROCs you will give. So preparation of the gate paper becomes easy in the classroom only. Think properly with the given data. Don't get emotion. Take the input Laplace and ROC 1 to 2. Transfer function ROC greater than minus. What is the intersection of them, sir? Common is 1 to 2 range. That way we solved the problem. At least answer me this right side funny question. That is also very simple model, sir. Right side example. What is the answer for right side question? Oh, this fellow has given ABC also. Good, good. Mr. Sandeep, very good. Solve the given equation. Very funny. This integral can be treated as yt convolved xt. It is looking like convolution formula, not sir. So when you apply Laplace, y of s plus y of s into x of s equals to xs plus 1. Take ys multiplier common. It becomes 1 plus. Take ys multiplier common, sir. 1 plus xs cancellation. Y of s is 1 means inverse Laplace is simply del t. As the lower limit of integration starts from 0, at least it should be mentioned in the problem that they are causal functions. If it is not mentioned, it implies that they are causal type only. If it is not mentioned, it implies they are causal type only. Generally, they have to mention that data. If it is not mentioned, we should feel that they are causal type, as the lower limit of integration starts from 0. This type of difficult questions, if I ask, then 20-30 fellows will answer immediately. Very difficult, na? Which is neatly looking like convolution formula. Okay, try this model. Consider a signal y of t equals to x1 of t minus 2 convolved with x2 of minus t plus 3. Find ys with ROC. Three properties we have to apply in the question set. Time shifting, convolution and reversal. Time shifting, convolution and reversal. By the application of three properties, decide the correct answer. By the application of three properties, decide the correct answer. Whether we have ROC or not, that you should tell me. Find ys with ROC is the question. Whether we have ROC or not. X1s we can write as 1 by s plus 2 sigma greater than x2s we can write as 1 by s plus 3 sigma greater than, both are right side signals. After taking Laplace here, y of s is what's that? E power minus 2s into x1s multiplied by e power minus 3s. Shift is positive. X of minus t means Laplace x2. As we want to multiply in the question x1s and x2 minus s, it is a valid product only when we have common ROC, sir. As we want to multiply x1s and x2. So what is x2 of minus s, sir? 1 by minus s plus 3. What is reversal ROC we studied? Minus r greater than minus 3 becomes less than minus r. So do we have common ROC or not? Common ROC lies between minus 2 to 3. For x1s it is greater than minus 2. For x2 minus s less than. Substitute the expressions. Common ROC lies between minus 2 to 3. Common ROC lies between minus 2 to 3. We want to multiply x1s and x2 minus s. That is a valid product only when you have common ROC. In this example, it is possible. You can blindly substitute the Laplace expressions there. We are in need of reversal property here. x2 minus s is expected greater than minus 3 becomes less than 3. Application of reversal, sir. Think about this question. Find the impulse response of a linear causal system described by this equation. Also determine the response to the excitation. Integral differential equation is given, sir. Asked for impulse response. If you want to get impulse response, first you should calculate transfer function ys by xs. E power minus 2s into e power minus 3s becomes what? E power minus 5s only. Here shift of 2 units, here shift of 3 units. Product karo. A power m into a power n is a power m plus n. Solve this model, sir. Integral differential equation is given, asked for impulse response. If you want to get impulse response, first you solve for transfer function ys by xs, sir. Solve for transfer function first. Y of s by x of s. Transfer function is always defined with zero initial condition. Transfer function is defined with zero. If you take Laplace of this one, sys plus 4ys plus 3 into ys by s equals to xs. When you take y of s common, s plus 4 plus 3 by s equals to, so the transfer function becomes ys by xs is s by s square plus 4s plus 3. After simplification, denominator roots are what, sir? S plus 1 into, so what is the partial fraction enjoyment? Solve for partial fraction here. Close this, s place minus 1 means minus 1 by 2. Close this, s place minus 3 means in the other term, as it is mentioned, system is causal. A linear causal system, what is the impulse response? Positive sided minus half e power minus t ut plus 3 by 2 e power minus 3t. It is neatly mentioned linear causal system. What is the question extended is also determine the response to the excitation. Input given, we want the output, sir. What is the Laplace of the input, sir? 1 by s plus 1 means s plus 1 by s. When you multiply this term and this term, what you are left with? Ys is xs into hs. After multiplication, what you are left with? 1 by, what is the inverse Laplace? E power minus 3t. Input known, system known, get the output means convolution converted to multiplication. Input known, system known, get the output means convolution is converted to multiplication logic. Who wants previous slide? Dekho. Anyway, it will be uploaded now immediately. Just a minute. First, we have completed the previous example. Input on, transfer function on, get the output. Direct question only. Think about this question, sir. This is given in one of the old ISRO paper. Funny example. For the interconnected shown in figure, combined causal impulse response is, this is V dash t. Maybe it is very light, sir. Dot is there. V dash t plus Vt equals to xt. Y dash t plus Y of t equals to Vt. Finally, he wants combined causal impulse response. Calculate transfer function of each block. Calculate the transfer function of each block. Transfer function of first block is 1 by s plus 1. Transfer function of second block also 1 by s plus 1. This is SVS plus VS equals to XS. VS by XS solve. YS by VS you solve. So overall transfer function becomes 1 by s plus 1 whole square. It is Laplace of which function? T e power minus t. Solve for the transfer function of each block. Yes. Take transfer function of each block 1 by s plus 1 into 1 by s plus 1, sir. 1 by s plus 1 whole square means Laplace of t times e power minus t ut. Think about this question. A causal LTA system has zero initial condition and impulse response h of t. Its input and output are related by some differential equation. Let another signal g of t is defined with the h of t as another relation. Number of poles of g of s it contains. 2 times you have to solve for transfer function. Solve for transfer function of each expression. Then you can say how many number of poles g of s is having. What is the Laplace of first expression? S square ys plus alpha s ys plus alpha square ys equals to x of s, such that the transfer function ys by xs is what's that? 1 by s square plus alpha s plus alpha. Similarly, what is the Laplace of second expression, sir? G of s equals to alpha square into hs by s. Integrator is 1 by s or not? S into hs plus alpha. If you take hs by s common, what is the enjoyment? Alpha square plus s square plus alpha s. H of s denominator, G of s numerator, they are looking like same. So how many number of poles are there for G of s? Only single pole at origin. Just to solve both expressions for transfer function. H of s denominator, G of s numerator, they are same, cancellations are. You are left with 1 by s. कितने बार जाना है माँ? एक बार गया फिर भी बोल रहे प्लीज गो बैक, प्लीज गो बैक. कितने बार जाना है देखो. 15 seconds टाइम दिया और होना है 32. देखो वो भी देखो. Solve for a transfer function of individual expressions. Then you will know number of poles of G of SR. Then you will know number of poles of. Till now, whatever the properties we studied, they corresponds to bilateral or two-sided Laplace. They corresponds to bilateral or two-sided Laplace. The next concept which we are discussing is unilateral or single-sided Laplace. Whatever I am explaining for next 20 minutes, listen carefully. Listen carefully, sir. Now the actual Laplace transform topic started. So it is called as unilateral or single-sided Laplace. Means one side. ULT. Unilateral or single-sided. To show variation in unilateral, I am using some stylish notation, textbook, some build-up like this. All that is overaction. Just you remember that if the lower limit of integration starts from 0, it means unilateral concept. Some fellows will say this as 0 minus also to say that impulse function also includes the limit. Some fellows will also say 0 minus instead of 0 to say that del of t also includes the limits. Okay? Listen. Whenever we want to solve a differential equation with initial condition, we are in need of using this property. Sorry, we are in need of using this transform. Everyone tell me, what is the unilateral Laplace of this function? I want the answer. E power minus 4t u of t plus 3 unilateral Laplace you want. U of t plus 3 indicates where the signal starts at. It extends from minus 3 to infinity. We want unilateral Laplace of e power minus 4t u of t plus 3. Because it is asked for unilateral Laplace, don't concentrate the signal for negative time. We should take only for positive time. For positive time, it is treated as what's that? E power minus 4t ut. Answer is 1 by s plus 4. Maybe we have applied time shifting property because it is unilateral Laplace. Try to check the signal only for positive time. Try to check the signal only for positive time. 1 by s plus 4 is the answer. 1 by s plus 4. Okay. What is the unilateral Laplace of del of t plus 3 plus del of t minus 5? Think and answer back. What is the unilateral Laplace of del of t plus 3 plus del of t minus 5? Come on, come on. You cannot take impulse at minus 3 because it is negative sided. Impulse at 5 positive sided. Normal time shifting e power minus 5s. Normal time shifting e power minus 5s. It means if you want unilateral Laplace of any signal, what you have to do? Multiply the given signal by step function. If you multiply the given signal by step function, what is the advantage we have, sir? If you multiply the given signal by step function, what is the advantage we have? Signal automatically covers positive time. Signal automatically covers positive. Okay. Whenever we are solving a differential equation using unilateral Laplace, the total response is taken as sum of two components. Normally in network theory, state response and transient response, they are called as zero state response and zero input response. Zero state response, zero input response. State of the system represents initial condition for us. State of the system means initial condition. Zero state means when you are finding out this term, all initial conditions are zero, but the input signal is applied. Zero state response. All initial state of the system means initial condition. All initial conditions are zero, but the input is zero. Input response meaning is there only. Input is not taken. All initial conditions are considered because it exists from initial condition. IC means initial condition. IC means initial condition. Zero state response means all initial conditions are zero, you are applying input. Zero input response means input is not taken, only with initial conditions we are finding the answer. But never mix the word zero state response and forced response. Never mixed the word zero state response and forced response. They are not having same meaning. To understand, in few minutes I am solving one example. Here differentiation in time property is repeated. Differentiation in time property is repeated again. Now with initial condition. What is the Laplace of d by dt xt, sir? S into x of s minus x0. What is the Laplace of d square by dt square of xt? S square x of s minus s into x0 minus x dash 0. Zero state response and forced response, they are not interchangeable words. Zero state response and forced response, they are not interchangeable. Whenever you want to solve a differential equation with initial condition, this is the property we require. One of our friend got tension where initial condition gone. Transfer function is always defined with zero initial condition. Now only we started initial condition models. Okay. Whenever we are solving any differential equation with initial condition, we are in a position to solve for two terms. One is called as zero state response, the other one zero input response. What is the meaning of forced response? First, let me explain that point for you. What is the meaning of forced response? Listen, sir. The input terms on the right hand side of differential equation is describing the forced response for us. The input terms that are existing on the right side of a differential equation will contribute to the forced response. So if the forcing function is taken like different forms, what is a form of forced response? Suppose you have given a simple constant like C0, sir. It is producing the answer like C1. Due to C0 constant, it is another constant C1. If you are taking input like forcing function like e power alpha t, that will produce C into e power alpha t. Suppose you want to give ramp function t, it will produce the answer as C0 plus C1. Suppose you are taking t e power alpha t, t into combination of both, then the answer becomes e power alpha t C0 plus C1 into t. If you are taking cos omega t plus beta, so it may be C1 cos omega t plus C2 sin omega t, or C cos omega t plus beta plus theta. This form you are going to get. Forcing functions are different. Zero state response is different. Forcing function is different. And zero state response is different. How to understand that? Let me solve an example. Y dash t plus 2 into y of t equals to 6 into x of t. Find forced response and zero state response for the input xt equals to 6 into ut. Listen carefully, everyone. We have taken a first order differential equation y dash t plus 2yt, y dash t plus 2yt equals to xt. What is the difference between forced response and zero state response? Now we are checking. We applied input as 6 into ut, sir. We applied the input as 6 into 6 into ut means it is a constant like 6 number. Anyway, it is there for positive time. Due to C0, you are getting C1. So forced response, first let us solve. Let us assume YFT, F for forced as C. Let us assume YFT as forced. What I mentioned, the input terms on the right side of the differential equation is contributing, is describing the forced response. Or better to say, the input terms on the right hand side of differential equation will contribute or describe the forced response. If I am assuming YFT forced response as C, 0 plus 2C equals to x of t. What is x of t here? 6 into u of t. I am substituting differentiation of constant 0 due to a constant C0. What is our answer? C1R. So y dash t means differentiation of C0. 2 into C equals to 6 into u. So C becomes 3. Actually C is a constant. Therefore the forced response answer is what? Therefore the forced response answer is 3 into u of t. But for the same question, what is the meaning of ZSR? What is the meaning of ZSR from our previous slide? All initial conditions are 0, but input signal is applied. What is input signal applied? 6 into ut. What is the Laplace? 6 by s. What is the Laplace of the apply Laplace to differential equation, sir? When you apply Laplace to differential equation, SYS minus Y0 plus 2 into YS equals to XS. As it is zero state response, we don't bother about initial condition. As it is, so Y of S into S plus 2 left side, XS is 6 by, so what is Y of S answer? 6 by S into S plus 2. Listen. S place 0 means residue 3, S place 0, S place minus 2 means residue. Now what is the inverse Laplace? Y of t equals to 3 ut one term minus 3 e power minus 2t ut is another term. Do we have difference in forced response and zero state response? Answers are not, or they are same. If you feel they are same, your solution is wrong. Before last year, wantedly for EC, this question was asked in 2019 gate paper, wantedly. Rohan, I will convey your information to that fellows. Okay. Just let me complete this topic for another 5-10 minutes. I will complete this topic. Okay. There is a difference between zero state response and forced response. I am explaining one more time. Listen. How to solve a differential equation using unilateral Laplace means total output is taken as sum of two parts, zero state and zero input. Zero state means state represents initial condition. When you are finding this term, all initial conditions are zero, but you are applying inputs. Zero input means input is not taken, all initial conditions are considered. But then what is forced response, zero state response difference? The input terms on the right side of a differential equation are contributing forced response. Suppose input contains a constant C0 as the input, output is C1. Suppose input contains e power alpha t. It has to produce C e power, if it is a RAM, C0 plus C1t. Like that, I solved one example here. Find the forced response and zero state response when you apply this as input. Because you have applied 6 into ut, that is a constant number or not? Ut, don't bother about it. Anyway, unilateral Laplace means we are solving for positive times. Okay. So if I assume C0, I should get output as C1. If I assumed the forced response as C, substitute here, differentiation of C0 plus 2C equals to 6, I got C as 3. So forced response is 3 ut. But if I apply Laplace to the differential equation, I got a different answer. Don't mix the words forced response and zero state response. To say that point only, I solved this simple example. Don't mix the word forced response, zero state response. In a similar way, zero input response, natural response are also different. Zero input and natural response, they are also different. Most of the textbooks, they will say forced response as zero state response, natural response as zero input response. There is an ambiguity in GATE 2019 paper. Luckily for A and D options, they have given the answer, but it will not happen every year. There is a difference in the word forced response, zero state response. Observe carefully. Don't mix them. Don't mix the words, sir. Okay. When the forcing function is like this is the equivalent form of the forced response you are going to get. We are going to solve so many questions. Don't be tensed. One example I have shown. Difference in forced and zero state response. Only one example I have shown for you. Okay. Due to C0, output is C1, sir. 6 into ut means you can feel this as 6 because when you are solving the problem, only you are solving the output for positive sided signal because now we are using unilateral Laplace or not. So 6 can be taken as C number. The input terms on the right side will contribute forced response. I am assuming that as C. Substitute in the differential equation. Differentiation of C 0. Next to 2C. Xt is given as 6 number. So solve for C. Therefore output is 3 into ut. 3 into. But zero state response means what is the Laplace of 6 ut? 6 by S. Substitute and simplify. This is the answer. These two answers are not same. These two answers are. So what I want to tell you from this example is forced response, zero state response, they are not the same. Forced response, zero state response, they are not same. Last example for today, which contains both the terms. I hope you have completed. I will go to next slide. Suppose the example is given as this. Solve y dash t plus y into yt equals to xt. Given xt equals to ut and initial condition y0 equals to 1. Means he wants to solve for output, nothing specific, zero state or zero input. In our previous question, force response, zero state response, we want separately. But this example just solve the differential equation with initial condition. So what is the Laplace of this expression, sir? Sys minus y0 plus 5 into ys equals to xs. If I take ys common on the left side, s plus 5. Take y0 number on the right side, 1 plus 1 by s. y0 is 1, sir. That is given. Ut Laplace 1 by s. So y of s can be selected as s plus 1 by s into, do partial fraction. S place 0 means, s place 0 means what is the residue? 1 by 5. S place minus 5 means minus 4 by minus 5 means the inverse Laplace is 1 by 5 ut one term plus 4 by 5 e power minus 5t another term, sir. In this question there is no ambiguity because it is asked for complete response. But in the previous example he wants forced response, zero state response separately. You cannot mix them, forced response, zero state response. But in the last example which we solved, solve the equation means solve for output which contains input and initial condition. So dyt by dt Laplace sys minus y0. Ys you take common, s plus 5 is the multiplier, y0 you take on the right side, sir, 1. After simplification you will get the complete answer. This is complete output, this is only part of the output. Forced response or zero state response, not complete, part of the output. The standard formulas which you require in Laplace transform, I am adding that as a slide. Study standard formulas which you require in this chapter, sir. These are the formulas we discussed today. Okay. Last problem I solved for complete output which includes input and initial condition, means zero state, zero input response combinedly we solved. It is not separate. These are the models we studied today. Some formulas, not every combination, some of the formulas. So main observation we have done today is forced response means due to input. Zero input response. When you are solving zero state response, from where y0 will come? Zero state response meaning is what? What I have shown in the previous slide, all initial conditions are 0. If initial conditions are 0, when you are finding zero state response, no initial condition. That is the reason in the next slide I solved both with initial condition, with input. We applied at a time. Zero state response is there, zero input response is also there. When you are finding out zero state response, no initial condition. That is the reason cancelled. I cancel y0. State means initial condition. With all initial conditions 0 only, we are finding that. Okay, these are some relations, not every relation. Some relations we studied. Tomorrow's class we are going to study initial value, final value theorem, some constraints on them, causality, stability of Laplace domain. Approximately 1 hour discussion, 1.5 hours it will take. After that we are shifting to discrete form of transforms, DTFT, all that. Okay. For today I am stopping. I think most of you got heat in your brain. Even myself also continuously speaking. For today, I'm stopping. Tomorrow, 5 o'clock sharp. Class is at 5 o'clock sharp. Tomorrow's class is 5 o'clock only, na? Your college is there till 9 o'clock. You think of, you should manage. Corona has made the things like that. You should manage the situation, sir. Okay? स्नैपशॉट वाले इमोशनल फेलोज देखो, इधर एक some fellows want formula वाले. They are going to upload immediately after half an hour. You can cross check complete information of today. अरे दिखाया ना, कितने बार पूछते रहे, फार्मूला वाले दिखाया ना, फार्मूला वाले बोल के.
Audible, sir.
Tell me.
Sir, in zero, in zero state response, can we say that the first term belongs to force response?
No. Luckily, the model which I selected, you got like that.
No. In the 2019 question, also the same pattern.
Yes.
Was there. The answer was
only UT. That pure contribution is due to only UT.
Right. So only we are going to get only one term which is related to x of t, na?
Yes.
So from that also we can recognize that first term is.
Yes. But most of the fellows, they will treat even pro case, monologue, standard textbooks only. They will say zero state response, forced response, they are same, but there is a difference. For giving that clarity only, I solved that specific exam.
Okay. So my question was, if we calculate zero state response, that first term every time.
So, due to the input, whatever is there, you can pick it.
Okay. I did a mistake in that. I select entire equation.
Okay.
I went wrong.
Okay.
Okay, sir. Thank you, sir.
Hello, sir. Sir, 33F, sir. Sir, I didn't get that problem.
What is asked here? Two blocks are connected in series. He wants causal impulse response. How to get impulse response? If you know transfer function, blocks in series is product, na? Solve for transfer function of this one. S plus 1 into Vs equals to Xs. S plus 1 into Ys equals to Vs. These are the transfer function. First you solve for Vs by Xs, 1 by S plus 1. Here Ys by Vs is 1 by S plus 1. That I have written directly. Product is what? 1 by S plus 1 whole square. Inverse Laplace is what? T times e power minus t ut. You are not in a position to solve this differential equation. S plus 1 into Vs equals to Xs. So Vs by Xs is 1 by... You can't solve that?
Yes, sir.
That only asked.
Okay, sir.
Hello, sir. Sir, 17F.
1 minute.
Sir, here, sir, I'm getting doubt like how we are taking sigma greater than -1 and lesser than 1.
Oh, you have not attended introduction today?
I attended, sir.
Multiplied by ut means right side signal or left side signal?
Right side, sir.
ROC is greater than that pole, greater than -1. multiplied by u minus t means left side or right side?
Left side.
So ROC less than that 4. Over.
Okay, sir. Okay, sir. Sir, and last problem, sir.
Which last problem?
Today's last problem. 36.
How to differentiate forced response and zero state response? That explanation I have given. 6 into ut means it is a constant number or not for positive time.
Yes,
So
sir.
forcing function, when you apply C0, C1 directly substitute in the differential equation. The input terms that are existing on the right hand side will contribute forced response. If I substitute C, differentiation of C 0 sir. Next to 2C equals to 6. C is 3 means forced response 3 ut. But if by applying Laplace, if I solve, I will get zero state response. So zero state response answer is different. Forced response is different. They are not same.
Sir, here how we got to y of 0, sir?
Where y0 is not there. Zero state response means initial condition is 0 na.
We need to subtract that, sir.
Arey, how will subtract bacha? With initial condition, this y0, you solve how you got this differential equation means you solve by using unilateral Laplace. You will get that initial condition. But when you are solving zero state response, no initial condition, sir. Next problem, I substituted initial condition because nothing specifically I asked. I want complete output.
Okay,
So I
okay, sir.
included initial condition and input. Both are included.
Okay, sir. That is present in formula only.
Yes. You have to solve how you got initial condition. Network theory में नहीं बताया.
Okay.
Okay. Huh?
Good differentiation in time you have explained. Here you have written
That is bilateral. That is bilateral means minus infinity. This is unilateral. You should take fast memory also into consideration.
Okay, sir. Okay, sir. Got it, sir. Thank you.
Sir, page number 24, sir.
24.
Sir, if you given అంటే ఇప్పుడు ఒకవేళ కన్వర్ట్ చేసాన్ని ఇవ్వకపోతే సార్
ఇవ్వకపోతే దానికి ఏదైనా వచ్చు నేచర్
లైక్ లెఫ్ట్ హ్యాండెడ్ వస్తుంది రైట్ హ్యాండెడ్ వస్తుంది
ఏదైనా వచ్చు అంటున్నా కదా నేనే చెప్తున్నాను
ఓకే సార్
ఫైనైట్ లెంత్ కాకుండా ఏదైనా వచ్చు అదర్ దాన్ ఫైనైట్ లెంత్
ఓకే సార్ థాంక్యూ సార్
Good evening, sir.
Good evening,
So,
sir.
is a transient response same as a zero input response?
No. For stable systems only. All that explanation tomorrow I'll give you. Still,
Okay,
today I stopped. Last 5 minutes only I have given explanation. Tomorrow
Okay, thank you, sir.
that is there.
Hello, sir.
Yes, ma'am.
Sir, page number 18F.
तो 33 के लिए इतना सताया मेरे को 33 बोल के आप हाँ बोलो माँ
Sir, this right side question.
हाँ what happened
I did not understand like how sigma is last one is ranging from -1 to 2.
not raising that is one of the ROC study the question properly how many chances of ROCs are there only chances it is not asked for stability or causality like that one chance right of the rightmost pole sigma greater than 2 another chance less than -3 left of the leftmost two-sided means -3 to -1 we can pick -1 to 2 also we can pick we cannot pick -3 to 2 because it includes a pole so 4 chances are there number of chances is asked question
Okay, sir. That's it. Thank you.
enjoy
Hello.
hello
Hello. Good evening, sir. Sir, 21F.
One minute. Where is that background
Akka, మెల్లగా మాట్లాడు.
for 2 minutes let them speak.
Hello. Yes, sir.
Tell me
Sir, I didn't understand this, sir.
I asked by giving one sine wave for one cycle I want what is the Laplace of this function normally array who is that background your family only ma
Yes, sir. I'm sorry.
Request them.
Yeah.
Just request them to.
Okay, sir. Okay.
Otherwise, I have to shout.
Okay, sir. I'm sorry. Yes, sir. Tell me.
అమ్మా నమస్తే దయచేసి కాసేపు సైలెంట్ ఉండడం ఒక 2 minutes ప్లీజ్. Normally this is a sine function with certain amplitude ma a sin omega naught t. It is defined for 0 to pi means I can multiply by this bracket term ut minus q of t minus pi. Okay.
Okay.
So sin omega naught t ut we have a predefined formula, but second term to get we need adjustment here t minus pi plus pi. So I don't want to waste that time. First I have taken sine wave for complete positive cycle, complete positive time. After pi we don't want that signal na? So I started shifted version of the same signal with negative amplitude. Once I add these two, I got the answer directly without any adjustment.
Okay. Okay.
Okay.
Here 20 by s square plus.
Array omega naught is
Just addition of these two, na sir?
Addition of these two is overall Laplace ma. Omega naught is 2 na. 10 into 2 amplitude 10 is there. 10 into 2 s square
Yes,
plus
yes.
2 square.
Okay. Okay. Okay, sir. Thank you, sir.
Hello.
Hello. Good evening, sir.
Good evening. Ma.
Sir, forced response you explained theoretically, but practically, how do we define it?
What practical?
Forced response.
Due to the input whatever we are getting, that is what is the input I applied in that slide? Ut. Due to ut whatever contribution is there, that is forced response. It is not due to complete term. It is 6 into ut is producing output as 3 into ut. Suppose here I have given 6 into e power minus 3t ma.
Yes,
I may
sir.
get the new answer like c into e power minus 3t. Whatever the input I will give, similar form I will get. That is what this left side table na.
Okay. 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 That's all. Thank you, sir.
Hello, sir. Sir, 20F.
Who is this? 20F. Yes, ma'am.
Sir, here in the right side question, I didn't understand how did we get A and T naught value?
What is mentioned in the question? Find the value of A and T naught such that Laplace of this function equals to previous answer. Just equate them. GS equals to XS, it is mentioned already. Equate the answer GS equals to XS. If you equate by comparison, what is A? Here extra minus 1 is there. Minus A equals to 1 means A minus 1. T naught also minus 1. Substitute. So,
Okay, sir. Understood. Thank you, sir.
Hello, sir.
Sir, how to identify whether the signal is unilateral or bilateral, sir?
they will mention, sir.
Okay, sir.
Any signal exists for positive time is unilateral only.
Okay, sir.
Good evening, sir.
Sir.
Sir, in page 6F.
6F, 1 minute. Who is the other fellow speaking?
Not me, sir.
No. 6F, 1 minute. Bolo?
Yeah, in this spectrum inversion, some you told about that formula, so Fs equal to.
This waveform is there, na? This waveform. The
Yeah,
inverted version of that waveform must appear here.
Yes, sir.
You do one thing. I have shown previous slides x of f minus nfs, na?
Yes, sir.
By assuming this FC 1200 means 1150 to 1250, you draw for 1600s, 100% you are going to retain. Whatever the positive baseband spectrum is there, the inverted version must appear like here.
Okay, sir.
So
So for this, you told one formula, no, sir. Without that, using that K formula, we can do this.
No, that will be lengthy, very lengthy.
Okay, I have to use this.
Why this? How this formula came? It is a big derivation. That is the reason I don't want to discuss.
Okay, sir. Sir, thank you, sir.
Yes.
Hello, sir.
Ah,
Sir, 36F.
ah.
Sir, here you have taken force response of Y is constant, no, sir. We can take like
Into UT means it exists for positive time. You can treat that as C naught, no problem. It is constant only.
okay. Based on that, we have taken
Yes.
Y.
Yes.
Okay. Okay, sir. That's it.
Is this Praneeth? Are you there, Praneeth?
Hello, sir.
Tell me.
Sir, is the discussion over on the force response, force on zero state?
What do you want?
No, sir. I'm just asking. I understood this. I want some more.
Tell me. What do you understand?
No, sir. I understood this. But
Okay.
tomorrow we will continue this, sir. We'll start.
Tomorrow we are continuing initial value, final value. Some linking topic is there.
Okay. Okay.
Still, it is not over.
Okay. Okay. Thank you, sir.
Hello, sir. Sir, can we say the forced response is the steady state term in zeros ZS, sir?
There are some conditions there. For stable systems, it will happen. You cannot say like that.
Okay, okay, sir.
Hello?
Hello, sir. Sir, 7F.
Which number?
7F. Sir, after finding the FS0 like 1150 megahertz, you are dividing like divided by 2, then you are checking in the answers that I did not understand the logic that why you are dividing by 2 and checking in the
stated
answer.
already that is the condition. To avoid spectrum inversion, this is the optimum sampling rate. For the first given data, I got 1150.
Okay.
M is only even integer. So 1150 by 2 is this number, no problem. 575 divided by 2 is this number. The only option that is failing is you are writing ISRO exam for 90 minutes. You cannot do research there. For
Sir,
80
if
minutes.
more than one answers are matching, then what to do? Like
ISRO में क्या है? ISRO का question है यार. ISRO. Still they have not introduced.
Okay.
Don't get
Sir,
involved.
Sir, on the zero state response on the post response, it will mention in question, right? Like
Yes,
find
they will ask. They will ask neatly.
And what is the ambiguity you were talking about? That I did not understand. That what will be the ambiguity? Then
Ambiguity is they will have a confusion in this term. Just wait.
I just want to know that confusion.
See, due to C naught, 6 into UT means it is a constant number for positive time. Due to 6, it is creating another number 3. But zero state response is not like that. After solving, it has introduced one more term also. So 3 UT, but what that fellow has done in the exam, both options are given. Some fellows have chosen second option as forced response, but he wants due to UT term only. What is the answer? Due to UT, it is contributing only 3 UT. This is different, this is different. Both are not same.
Okay, understood. Thank you.
Signals వచ్చింది. Force